This chapter is about the habits and frameworks that make FDE work reliable, repeatable, and easier to reason about. The goal is to turn scattered experience into a playbook you can use when the work gets messy. Auftragstaktik gives the role its real shape. The center defines the outcome, and the field decides how to achieve it. That shift matters because it changes the engineer from a support function into an operator with judgment. A forward-deployed engineer is not just a faster support rep with stronger technical skills. The important difference is autonomy. The organization cares about the result, while the person closest to the customer adapts the method to the situation on the ground. Mission-type tactics separate intent from execution. Leadership gives the goal, the boundary, and the constraints. The team in the field then picks the route, the tools, and the order of steps based on what is actually happening. In an FD setup, the central teams own the business target, but the field owns the local decision-making. That means the engineer can change a prompt, adjust an integration, or simplify a workflow without waiting for a slow approval chain. The real value comes from not escalating everything. Trust works when routine decisions stay at the edge, and only the cases that exceed local authority get pushed back to headquarters. This part explains why the role appeared in the first place. The useful part of the story is not the title itself, but the pressure that created it. Enterprise AI had to move from a demo into real work, with real users, controls, and constraints. The early challenge was translation. A model could look impressive in isolation, but customers needed it inside an existing workflow, alongside messy data, approval steps, fallback behavior, and security requirements. That mismatch is what made a new operating model necessary. One person had to understand the customer's actual problem, shape the product with the internal team, and still be technical enough to connect the two. The forward-deployed engineer fills that gap, because the work sits at the boundary between discovery and implementation. The pattern becomes clearer when it is broken into stages. First comes the platform, then a customer need that a generic interface cannot handle, and then a person who can adapt the system in place and feed the lesson back. The first step is capability. The second step reveals the limit of a standard interface. The third step is where the operating model starts to form, because the engineer learns from the real deployment instead of treating the customer site like a one-time project. That final step changes the job from support work into a learning loop. The goal is not only to help the customer succeed, but to understand their constraints quickly enough that the product gets better for the next deployment too. Mission-type tactics depend on a clear mission, because the field team can only act well when the goal, the limits, and the freedom to decide are all explicit. That balance is what lets enterprise AI move quickly without losing control. The headquarters team has to define the mission tightly enough that the field can make good decisions without constant checking back. In practice, that means three things have to be spelled out before anyone starts building. The outcome gives direction. It tells the team what success looks like in business terms, so effort stays tied to a result instead of drifting into technical activity for its own sake. The constraints protect the parts of the system that must stay intact. Those may be legal rules, security boundaries, reliability requirements, or brand-sensitive behaviors, and they keep local experimentation from crossing a line. Decision rights define where the field team has authority. If that is clear, they can move quickly on local choices instead of waiting for approval on every small adjustment. Once the mission is set, the field team handles the actual mechanics of delivery. That includes the workflow, the prompt or tool chain, the integrations, the evaluation plan, and the trade-off that shape how the system works in front of customers. This sits between consulting and product support. Unlike slow consulting cycles, the work cannot stall in long rounds of scope negotiation and sign-off. Unlike a simple ticket queue, it also needs deep context and direct judgment. The middle ground is fast, trusted iteration. Some of these words need a sharper definition if the reader comes from outside enterprise software. The next terms pin down how AI deployment, tactics, and handoff behave in a business setting. Enterprise AI means the system has to work inside a company's operating rules. Access control, approval chains, governance, and reliability expectations all shape what can be built and how it is used. Deployment is bigger than releasing a model. The real question is whether it fits into a working business process and can be used reliably by the people who depend on it. Tactics are the practical choices made close to the work. They turn an abstract objective into something that actually runs, which is why they matter so much in field-led delivery. Handoff happens when the customer no longer needs daily help from the FD. At that point, the system is stable enough, documented enough, and understandable enough for the customer team to carry it forward. The important distinction is autonomy with discipline. The FD is not just adapting passively to whatever the customer asks for. The role is to run a local decision loop that can move fast while still staying aligned with the mission. If every choice has to go back for approval, the delivery model has lost the very thing that makes it work. At that point, the team is acting more like a committee than a field engineering group. Reporting discipline is what keeps mission-type tactics from turning into constant escalation. The point is to separate ordinary field judgment from the rare cases that genuinely need headquarters. Routine choices should stay with the person closest to the work. If every small adjustment goes upward, the field stops acting like a field team and starts waiting for permission. Escalation belongs to problems that change the mission, exceed local authority, or create real risk. That filter matters because not every uncomfortable moment is a headquarters problem. Most of the day-to-day work should never leave the team. Once that rule is clear, the examples become easy to judge. If the customer changes how the work flows, the prompt can change with it. That is a normal adaptation, not a crisis. Queue order is a local operating choice. The team can test a better sequence without stopping to ask for approval. Logging is a practical fix when a system is hard to inspect. It improves visibility right where the problem is happening. Thresholds should move when the evidence changes. If the system is behaving differently in practice, local tuning is part of responsible operation. When users skip a handoff, the process is telling you something. Simplifying the step is usually better than treating the symptom as an exception. None of those changes needs emergency handling. They're the steady work of making the system fit the real environment instead of the ideal one. A blocker is different because local judgment runs out. At that point, the issue needs another decision maker, another resource, or another layer of review. Authorization limits are hard boundaries. If access itself is missing, the field engineer cannot safely proceed without help from the right owner. Security and privacy issues need formal judgment because the consequences reach beyond the immediate task. Those are not handled by improvisation. When the product itself cannot support a safe workflow, the problem is larger than a field fix. That is a design constraint, not a local tweak. Contracts and procurement can decide what can ship at all. If the rules change the deployment path, the field needs the people who control that process. Some failures are not local tuning problems. When reliability depends on changing the platform, escalation is the honest move. Escalation has a real cost. Too much of it slows the customer, trains the field to depend on headquarters, and erodes the habit of making sound local decisions. The strongest pattern is not silence and not constant escalation. It is a split rhythm, light reporting for learning and fast escalation for genuine blockers. Routine learning can come back in short notes, shared logs, or deployment summaries. Blockers move immediately because they require a decision or risk call that the field cannot make alone. The goal is not more noise. The goal is communication that is selective, timely, and useful enough to support real ownership in the field. This idea explains how rough, manual work turns into a dependable process that ordinary people can use. The useful part is not the demo itself. It is the engineering that removes friction and makes the path reliable. The gravel road and the paved highway are a simple contrast. One works, but only with effort. The other carries traffic smoothly. That shift captures what good applied engineering looks like in customer-facing work. At the beginning, the workflow depends on people stitching everything together by hand. That creates delays, inconsistency, and a lot of dependency on the few people who know where the problems are. The real job is to change the system, not just talk about what it could become. That means removing manual work, tightening the process, and making the result dependable enough to trust. A concrete example makes the pattern easier to see because the details show where the effort actually goes. Once the workflow is real, the gaps and constraints become much more obvious. A model that drafts responses can still fail as a product if people do not trust it or measure it. Without quality checks and escalation paths, it stays a demo that lives beside the real work instead of inside it. The engineer turns that demo into a system by adding structure around it. Intake is measured, easy and hard cases are separated, risky outputs get review, and real tickets become the basis for evaluation. Success is not just whether the model scores well in isolation. The stronger signal is whether people actually use it, whether it saves time, whether review effort drops, and whether the customer can operate it with less handholding. The process also teaches the team where the product is still weak. Repeated edge cases, confusing fields, and moments of hesitation point directly to the controls and changes needed before the system can scale. That is what a paved highway means in practice. The work is stable enough that regular users can follow it on their own. The system no longer depends on a specialist standing nearby to keep it moving. The role matters most at the seams of the product, where real system changes have to happen. The goal here is to show why an FDE needs to work across technical layers, not just give advice from the side. That claim only makes sense when the work is hands-on. A field engineer has to shape real parts of the solution, often in more than one layer at the same time, because customer problems usually span code, data, and operations together. The range can be broad, and that is the point. The same person may need to move from application logic to deployment concerns and then into customer workflow details without losing the thread. Sometimes the work starts in the application itself. That might mean a thin layer around the model, the logic that coordinates prompts, or the code that decides what happens in each step of a workflow. Data work matters because model behavior depends on what it sees and how it is measured. Sample sets, labeling rules, retrieval inputs, and logs all help turn vague complaints into something the team can inspect and improve. The infrastructure layer is where a good idea becomes something dependable. Deployment settings, permissions, monitoring, and routing all affect whether the system can actually run safely in the customer's environment. Workflow design is about the human path through the system. If the steps are awkward or unclear, even a strong model can fail because the person using it cannot move through the task smoothly. Security is part of the build, not an afterthought. The engineer has to decide which data can flow, what must be hidden, and where a human review step is required before anything leaves the system. Handoff closes the loop with the customer. Good documentation, training, and runbooks make the system usable after the team steps back, and the ownership model makes clear who carries it forward. That mix is why the role sits between categories. The FD has to cross boundaries because the customer's problem crosses boundaries, and no single layer tells the whole story. The engine can be strong and still go nowhere without the rest of the system around it. Roads, gates, dashboards, and instructions turn model capability into something that people can actually use and trust. Mission work only succeeds when the team can uncover the real problem, not just receive a request at face value. That discovery work is part of the job, because the wrong problem leads to the wrong solution. A mission-type model depends on contact with the real world. If the field is too far from the customer's situation, it starts optimizing for assumptions instead of facts. That is where discovery starts. An FD is not handed a precise spec in most cases. Instead, the customer gives an early signal that points toward friction, risk, or delay. Saving time may sound like a simple ask, but usually hides a slower workflow underneath. The real issue might be manual steps, repeated review, or too many handoffs. A trust problem often means the model is not the only concern. People may need clearer evidence, better calibration, or a way to inspect why a result was produced. Approval flow can be the real constraint even when the model is accurate. If the process cannot accept the output cleanly, adoption stalls no matter how good the prediction is. In regulated settings, safety is usually tied to policy, traceability, and controls. The technical answer has to fit the compliance environment, not just the model benchmark. Each one points to a hidden condition in the customer's world. The first task is to read the signal correctly before jumping to implementation. That translation is the core of the work. Often the bottleneck is somewhere unexpected. The review queue, the intake data, the governance policy, or another process around the model. Discovery is not separate from deployment. It is part of getting the deployment to fit reality. Reliable systems depend on the handoff between machine output and human judgment. The question here is where that seam sits and how to design it so the workflow stays safe, clear, and manageable. That seam is the critical boundary in any semi-automated process. If it is vague, errors slip through, or people waste time fixing routine mistakes by hand. If it is well designed, each side does the part handles best. Good design starts by forcing these decisions out into the open. Once the roles are explicit, you can test the workflow instead of just hoping it behaves well. Start by assigning the model the work it can do cheaply and consistently, such as sorting, drafting, or extracting structure. That gives the human a head start instead of making them begin from scratch. Human review belongs where judgment, ambiguity, or risk is highest. The person does not need to inspect everything. They need to inspect the parts where a wrong answer would matter. A good system knows its limits. When confidence is low, the input is unusual, or the cost of a mistake is high, it should stop the automation and hand control to a person. Logging matters because reliability depends on traceability. Keep enough evidence to explain what the system saw, what it produced, and who approved the final action. Only low-risk failures should be retried without a person involved, such as temporary network issues or short-lived service errors. Anything that might repeat a bad decision needs a different response. Audit trails are essential when you may need to reconstruct a decision later. That usually includes approvals, edits, routing choices, and any action that affects a customer, a record, or a regulated process. The level of control should match the environment. In lighter settings, keep the loop short and make uncertainty visible so the user can move quickly. In regulated settings, the workflow itself has to enforce review, permissions, and evidence. That same discipline shows up in eval-driven deployment. A good eval is a practical test against real tasks. So when a system changes, the team can tell whether behavior improved or drifted in a risky direction. When the prompt, routing logic, or retrieval source changes, reliability has to be measured again. That makes the system governable, because the team can connect each change to a specific shift in behavior and decide whether it is acceptable. This part maps the operating model for a field role and a headquarters role. The point is to make ownership, escalation, and learning explicit so the team can act with less friction. Each row pairs a central decision with a local responsibility. Headquarters sets the outcome, boundaries, and support model, while the field role turns that into action at the customer site, reports real blockers, and feeds patterns back into product. That is why the role cannot stay vague. Once the expectations are written down, people know when to act, when to escalate, and how to hand the work back without creating dependency. This matters because employers care less about isolated model skills and more about whether someone can make AI work inside a real workflow. The real test is turning a clever model into something that fits business constraints, users, and day-to-day operations. A lot of projects break not because the model is weak, but because the handoff into the workflow is messy. Companies want people who can bridge that gap and turn an API call into something employees or customers can actually use. That skill mix tells you something important. The role is not just coding, and it is not just strategy. It is owning a local problem, talking to the people affected by it, adapting fast, and still keeping the larger system in view. This part turns the origin story into a usable rule. FDE exists because someone at the customer edge has to make the model work in the real world, not just on paper. The important question is what authority that person needs and what must still be reported back up the chain. A plain language explanation helps because it keeps the role tied to a real business need instead of a title. The goal is to show that FD is not just technical support. It is the bridge between a model and a usable workflow. That combination matters because local decisions keep the work moving when conditions change on site. At the same time, disciplined reporting prevents headquarters from being flooded with noise and keeps attention on real blockers and useful lessons. When those two pieces work together, a pilot starts to behave like an operating model instead of a one-off experiment. That rule carries forward into the process view, where the same idea gets broken into steps you can actually run. The metaphor changes from a picture into an operating method, which is where the lesson becomes practical. The idea here is a practical framework for turning custom work into product capability. It matters because it shows how field work can shape the core product without jumping straight past the hard part. Treating this as a tool changes how an FDE works. Instead of repeating one-off fixes forever, the engineer uses the pattern to decide when a custom solution is ready to become something reusable. The sequence starts with one customer because real needs show up there first. From there, repeated patterns across customers become the signal that something is ready to be lifted into a shared platform. Each step has a different job. First, you solve the immediate problem, then you look for common structure, then you separate the reusable pieces, and finally, you make those pieces robust enough to live in the product itself. The skill is judgment at the boundary. Some details stay customer-specific, some patterns become platform components, and some lessons go back to the product team, so the next deployment starts from stronger base. A support intake workflow makes the role of a forward-deployed engineer concrete, because it shows how an early customer need can become a product shape. The point of this example is to follow one messy use case from custom setup to something reusable. The starting point is a real operational problem. People send in requests, and someone has to decide where each one belongs. When the system is still rough, the hardest part is not the model itself, but the environment around it. When people write in their own language, the model has to interpret vague, incomplete, or inconsistent wording. That uncertainty is where routing errors begin. A single problem can have several names depending on who is talking. If those labels are not aligned, the model has to map between business vocabulary, not just text. Trust is the other big barrier. Even a decent prediction is not enough if humans want a checkpoint before anything changes in a real workflow. An FD begins by shrinking the problem until it can be made reliable for one team. That narrow focus is what turns an abstract model into something the customer can actually use. The first move is to build for one customer's exact workflow. That means the solution is shaped by that team's data, process, and risk limits rather than by a generic ideal. Bespoke software is narrow by design. The engineer is optimizing for the real constraints of one environment, because that is the fastest way to get something useful working. That first build usually touches more than a model prompt. The work spans integration, data cleanup, business logic, and the human path around the model. The model has to live inside the customer's existing tools, not beside them. Integration is what lets the assistant see real tickets and produce real outcomes. Raw support text is usually messy, so normalization removes noise and makes the inputs more consistent. That improves both routing accuracy and downstream review. The language of the department matters because internal shorthand carries meaning. The routing logic has to reflect that local vocabulary instead of assuming a universal one. Uncertainty should trigger a human check rather than a blind guess. That keeps the system useful without asking it to be trusted everywhere on day one. The output only matters if it fits the customer's actual process. Wiring it into the workflow reduces friction and makes adoption realistic. That mix is what makes the role broader than just conversation with a customer. The engineer has to understand how the system behaves technically and how people will operate in practice. The first deployment is usually a bundle of small, practical pieces. Each one reduces risk and makes the assistant easier to trust. A thin service can sit between the customer system and the model, handling calls and orchestration. That keeps the setup manageable. A label map translates customer-specific categories into a consistent internal structure. That avoids confusion when different teams name the same thing differently. Logging matters because the team needs to inspect why the system chose a route. Without that record, debugging and trust both become harder. Guardrails limit the blast radius of a mistake. If the model can only suggest or cue work, a bad prediction stays recoverable. Edge cases need a place to land safely. A review queue gives humans control where the model is still uncertain. It helps to compare the workflow before and after the engineer gets involved. The contrast shows why the first deployment is valuable even before it is fully productized. Before the system, people do the routing by hand. That means every request depends on attention, memory, and individual judgment. After the deployment, the assistant takes over the repetitive slice and defers uncertain work to people. That shortens the time to first action without removing oversight. Measurement should track whether the system is actually being used and trusted. Routing share acceptance without rework, and time saved all tell you something different about success. The deployment also teaches the team what matters structurally. That feedback is often more valuable than the first automation itself, because it shapes what gets built next. That first win does not need polish. It needs enough reliability to prove the workflow is worth improving. Once one deployment is working, the engineer starts asking what keeps showing up again. Repetition is the signal that a one-off project may contain a reusable pattern. A repeated need is stronger than a single request because it points to a shared shape in the market. The engineer is looking for what is common, not just what is annoying. That shift changes the job. The same work that solves one account can reveal what the product ought to standardize for many accounts. Looking across accounts, the engineer begins to compare pain points. Once the same requests keep returning, those requests stop looking accidental. That means the assistant cannot route on text alone. It needs to verify facts against a reliable system before making a decision. Confidence thresholds are a product requirement, not a one-time preference. When reviewers keep asking for them, that tells you the decision boundary needs to be visible and configurable. Audit logs are a trust feature. They let people inspect the path from input to output, which is essential in a governed environment. Those repeated requests matter because they are stronger than local noise. They show that several customers are wrestling with the same underlying problem. A useful question at this stage is whether the same thing keeps getting recreated by hand. If the answer is yes, that piece is a candidate for standardization. When the same normalization code or approval screen keeps appearing, the system still depends on manual effort. That is the sign that the work is not yet stable enough to treat as a platform. The team can use a simple prioritization sketch to decide what deserves attention first. It is not a formula for truth. It is a way to make trade-offs visible. This expression combines the main forces at play: how painful the problem is, how much value the fix creates, how realistic the work is, and how quickly users feel the benefit. The exact numbers matter less than the conversation it creates. The point is direction, not precision. A painful, valuable, quick win deserves attention. A risky, slow win may still matter, but it probably needs a smaller pilot first. A concrete case makes the trade-off easier to see. Once you score a real workflow, the ranking stops feeling abstract. If analysts are spending hours sorting requests, the pain is obvious. The kind of manual work is a strong signal that automation would help. Faster routing improves the whole support chain, not just the intake step. When first action happens sooner, resolution usually follows sooner too. Moderate feasibility means the work is possible, but not clean. Messy data usually raises the engineering effort, even when the business case is strong. A short path to value matters because it lowers risk. If one department can pilot quickly, the team gets real feedback without waiting for a large rollout. Put together, those factors point to a workflow worth continuing. It has pain, value, and a path to learn quickly. When the same pieces keep reappearing, the work should start to move in a shared infrastructure. Abstraction is how a field solution turns into something the whole company can reuse. That separation is the core of platform design. The team keeps what varies close to the customer and lifts what repeats into a shared layer. Once repetition is obvious, rebuilding the same thing for every account wastes time. A shared layer turns repeated effort into maintained product. Normalization is a classic reusable piece because every customer needs the same raw input cleanup. Standardizing it makes later deployments faster and more consistent. A configurable confidence display gives each team control over how much certainty they want to see. That keeps one platform flexible enough for different risk tolerances. Approval handling is another repeated pattern, so it makes sense to package it once. The product can then enforce the same safety structure across accounts. A common audit format is valuable because it supports debugging, compliance, and trust at the same time. Shared observability is usually a platform feature, not a customer-specific one. Connectors are often best reused centrally because the same integration pattern shows up again and again. That reduces duplicate engineering across accounts. The goal is not to erase customer differences. It is to decide which parts must stay flexible and which parts are ready to become dependable product. A clean split makes the design easier to reason about. Some parts belong to the customer's policy and vocabulary. Others belong to the shared platform. These are the things that depend on local business practice. They vary because each customer organizes work differently. These are the pieces that should behave the same everywhere. They are the plumbing of the product, so reusing them saves time and reduces mistakes. The engineer's judgment matters here because timing is the hard part. Harden too soon and you freeze the wrong design. Wait too long and everything stays custom forever. A checklist is useful because it turns a fuzzy judgment into a repeatable conversation. It helps the team decide what belongs in the product and what belongs in the account-specific layer. Repeated work is the strongest signal that something should be shared. If the same step appears everywhere, it should not stay hidden inside a custom build. Anything tied to policy or local vocabulary should usually remain configurable. Those details often vary too much to bake into the platform. If the same explanation is needed more than once, the interface or workflow may be unclear. That is a sign that the product needs better defaults or better documentation. Hand rewriting is expensive and fragile. Repeated manual work usually means the team has not yet captured the right abstraction. If a piece of the workflow needs ongoing ownership beyond the field team, that is a clue it belongs in the core product. Product ownership is what makes the feature durable. That separation is what allows scale without flattening customer needs. Once the line is clearer, the team can build each side with the right expectations. The final move is to make the reusable parts dependable enough for wider use. Hardening is where a field workaround becomes a core product feature. A hardened feature can survive real usage, not just a demo. It has tests, support boundaries, security controls, and operational clarity. That change matters because ownership changes with it. The team no longer treats the feature as temporary scaffolding. It becomes part of the system people depend on. The work of hardening is practical, not cosmetic. It usually means strengthening the parts that matter when usage grows. Better tests catch regressions before customers do. They also make future changes safer. Monitoring helps the team see failures, slowdowns, and unusual behavior early. Without it, support becomes guesswork. Clear failure modes make the system easier to operate because people know what went wrong and what to do next. Ambiguous failures are expensive. Access control protects the workflow and keeps sensitive actions limited to the right people. That is especially important in enterprise settings. Documentation turns the system into something others can understand and operate. It reduces dependence on the original builder. The system is only truly productized when other people can support it. If every issue still requires the original engineer, the work has not fully transitioned. The paving metaphor captures maintenance burden well. Gravel can function, but it demands more intervention every time traffic increases. Paving does not remove upkeep, but makes the road dependable enough for broader use. That is what product hardening is doing here. Once the work is hardened, the signs are visible in how people use it and who maintains it. Those signals tell you the feature has crossed into standard practice. If people can use the workflow on their own, the system is becoming trustworthy and practical. That is a strong sign of maturity. Fewer exceptions means the process is settling into a repeatable pattern. The system is handling more of the routine work. When support can answer the same kinds of questions the same way, the feature has become easier to own. That is healthier than a constant stream of special cases. A runbook means the customer can operate the system without relying on tribal knowledge. That is what makes the deployment sustainable. The real finish line is operational independence. Once the customer can use the system reliably on their own, the field work has become lasting product value. This frame shows the full operating pattern. Start with a custom fix, look for repetition, extract what can be reused, then harden it into the product. That sequence matters because it explains how the role creates value without getting trapped in one-off work. A useful way to read the table is as a pipeline from one customer's pain to product capability. Each stage changes both the customer workflow and the team's understanding, so the work becomes less ad hoc and more durable over time. That balance is the point of the model. If the work stays only custom, it never scales. If it becomes product first too early, it misses the real problem. The table keeps both pressures in view, so the team can learn from customers while still building something reusable. The human/AI seam is the point where automation stops and human judgment still matters. That boundary has to be chosen carefully because it determines both safety and usefulness. A seam is not just a technical line in the system. It is an operational decision about responsibility. The model may generate a result, but a person may still need to approve, edit, or correct it before it is used. Strong FDE work does not try to erase that boundary. It makes the boundary clear because the right split between machine and human is often what makes the solution reliable in the real world. The exact split depends on the task and the risk. A safe design in one workflow may be too slow or too loose in another. One common pattern is recommendation plus approval. The model can narrow the choice quickly, but the person keeps control over the final decision when the consequences matter. Another pattern is draft and edit. The model saves time on first pass writing, while the employee keeps the tone, accuracy, and customer context aligned with the job. A third pattern is selective automation. Low-risk work can flow through automatically, but uncertain or sensitive cases remain with people, so mistakes do not scale up. In regulated or sensitive settings, the value is not full replacement of people. The value is a workflow that uses automation where it is safe and leaves human control where accountability is required. That field perspective is why demos can be misleading. A feature may look neat on a screen, but if it does not match how the customer actually approves work and assigns responsibility, it will break down in production. Prioritizing field work becomes easier when you ask whether a fix helps only one account or exposes a pattern worth reusing. That distinction tells you where the work can create the most leverage. A single account issue can still matter because customer pain is real. But the bigger signal is when that one case points to a broader platform need, because then one solution can help many places instead of just one. That combination changes the decision. The local fix solves an immediate problem, while the pattern gives engineering a reason to spend time on something that will pay off again later. That ability is why field-focused work stands out in the job market. It shows customer empathy, technical judgment, and the habit of turning what you learn in one place into product value that scales. The main idea here is a simple working rule. Start small, look for patterns, and then turn those patterns into something reusable. That is the shift from one-off help to a capability the whole company can depend on. The process is easier to remember than it sounds. There's a clear sequence behind the work, and once you can name the sequence, you can apply it in real customer situations. First, you work with a single customer and pay close attention to what keeps coming up. Then you separate the repeatable parts from the one-off details, because those repeatable parts are what can become a general solution. The last step is to make them robust enough to live inside the product, not just in a custom workaround. That is the job of an FD in practice. A fragile workflow might work for one customer because people are manually bridging gaps, but a shared capability means the company can support that same outcome reliably for many customers. The next step is to begin by understanding the problem before trying to solve it. Discovery comes first because it tells you what is actually repeatable, and that keeps you from building the wrong thing too early. Discovery first starts with the customer's real workflow, not with the solution you already have in mind. It matters because the first job is to understand where value is actually created and where the process breaks down. If the build starts too early, you end up automating the wrong process or adding complexity the customer does not need. That usually burns time, makes the project harder to trust, and leaves the original problem unsolved. Discovery first is a practical way to shrink ambiguity. You look for the real handoffs, the failure points, and the smallest change that proves value without creating cleanup work later, so the path from idea to production stays controlled. From here, the focus shifts to the actual steps. Observe the workflow, isolate the breakpoints, and choose the smallest intervention that earns confidence before anything scales. The first move is to locate the person doing the work, because that is where the real process shows up. The org chart can tell you who owns the task, but only the worker can show you how it actually gets done. sponsors and managers can describe the official path, and that still matters. The limit is that they usually describe the intended process, not the one people follow under pressure. Time beside the frontline worker is far more revealing than a status meeting. That is where you see the real steps, the delays, and the workarounds that never make it into policy documents. From above, work looks clean and linear. From the floor, you find shortcuts, handoffs, exceptions, side spreadsheets, and the manual copy-paste that keeps the process alive when automation falls short. That is the operational center of a job. If the goal is to understand where value is created and where friction appears, that is the seat to occupy first. A concrete example makes the gap obvious. The plan sounds smooth on paper, but the real route has turns, delays, and hidden checks. Keep that contrast in mind as the support workflow gets examined. The stated workflow often sounds neat because it leaves out the messy parts. It shows the intended sequence, which is useful, but it still hides how people actually resolve the hard cases. When someone shadows the support team, the actual path becomes visible. People search across tools, ask coworkers, and reuse old answers when time is tight. The important lesson is that edge cases and hidden context shape the job far more than the clean diagram does. Discovery begins with that messy route because that is where the product has to fit. Once the real path is mapped, the automation target becomes much clearer. This step focuses on where the work actually fails under real conditions. The goal is to find the points that create delay, rework, risk, or confusion, because those are the places where an AI system can help or fail. A process diagram often looks cleaner than the real job. What matters is where people slow down, switch tools, repeat work, or avoid using the system the way it was intended. The important failure is usually not the main task itself. It sits at the seam between systems, roles, or permissions, where information gets handed off and trust starts to drop. That distinction helps you see two layers at once, the official process and the real effort behind it. Once those are separated, the friction becomes much easier to locate. Each row shows the gap between the process as it is described and the process as people survive it. Those gaps are where work gets fragmented, and they often explain why automation fails when it reaches the messy middle of the job. The purpose is not blame. A clear map of the breakpoints gives you a better target for redesign, so you can fix the real constraint instead of arguing about the ideal version of the process. That mistake is expensive. You can automate a step that was never the bottleneck or polish an interface while a bad handoff still collapses the workflow. The useful work starts with the break because that is where the system is actually losing value. The point here is to prove value before spending time on production code. The question is which small change would remove the most pain or uncertainty. A discovery-first approach starts with evidence, not implementation. That keeps effort focused on the change most likely to matter. It is easy to move straight from observation into building. Better to search for the smallest intervention that gives the biggest reduction in pain or uncertainty. The answer is often something modest, not a full system rewrite. The useful move is to target the point where the workflow breaks down. A retrieval fix can matter when people cannot find the right source material fast enough, so the quality of the answer improves before any heavier logic is added. A triage prompt helps when inputs arrive in messy forms, because it forces the same structure every time and makes the next step easier. Guardrails matter when the cost of a wrong answer is high. They stop the system from sounding confident when it does not have evidence. Sometimes the intervention is not about the model at all. Moving review earlier can catch errors before they spread through the rest of the process. A better handoff reduces friction between people. If the next person can start with less clarification, the whole workflow speeds up. What is absent, there's a big leap to full autonomy. The early job is to find leverage, not to pretend the entire system can run unattended immediately. The real task is to choose the intervention with the most leverage, then test it in a lightweight way before turning it into production software. A prototype, a manual simulation, or a narrow workflow trial can give enough evidence to know whether the change is worth building. A simple sequence keeps the work disciplined. It turns a vague discovery effort into a concrete process you can repeat on day one. The sequence is meant to be practical, not ceremonial. Each step narrows the problem until the right fix becomes obvious. Start with a real person and trace the work they actually do, not the work you imagine. Then look for the exact breakpoint where time, quality, or confidence drops. Test a minimal fix there and measure whether the workflow improves enough to justify code. That balance matters. The method should be easy to hold in your head, but firm enough to stop open-ended analysis from drifting forever. It keeps the team moving toward evidence and away from endless discussion. The FDE touches far more than model prompts. The real job is to identify every part of the system that shapes whether the workflow works in practice. Discovery first does not replace engineering discipline. It gives the engineering effort a clearer target, so the team builds the right thing instead of polishing the wrong one. The exact scope changes with the problem. Some efforts stay close to software, while others reach into data, process, security, and operations. On the code side, the work might be very small and very targeted. A quick prototype, a routing decision, or a logging hook can reveal whether the workflow is usable before anyone invests in a full system. Data matters just as much as code. The wrong source, messy labels, or poorly structured documents can make a strong model look weak, while good data often changes the result more than a new algorithm does. Infrastructure shapes whether the system can survive contact with real users. Latency, authentication, monitoring, and rollback all decide whether the workflow is dependable when things go wrong. Workflow design is where the human and the model meet. You have to decide who approves, when a person steps in, what happens on exception, and how the work continues afterward. Security is part of the system, not an add-on. If the model can see the wrong data or take the wrong action, the whole workflow becomes hard to trust, even if the output looks good. Handoff is where the work becomes sustainable. Clear documentation, ownership, and training turn a prototype into something a team can run without relying on one person. That wider view is what separates a model wrapper from a real product workflow. The goal is a system people can trust in practice, use repeatedly, and maintain over time. The contrast matters because it shows why FDE work changes decisions, not just presentation. Before involvement, teams often debate in the abstract. After involvement, The conversation is anchored in real workflow, real friction, and measurable use. A good discovery-first engagement makes the difference easy to see on the board and in the product. That comparison helps the team stop arguing from opinions and start reasoning from evidence. Before FDE gets involved, the problem is usually not well pinned down. People know something feels off, but the shape of the workflow and the real constraint are still fuzzy. The workflow gets described in broad terms, which hides the actual steps people take and the places where they slow down or improvise. That often shifts the discussion toward features, because features are easy to name. The better question is where the process breaks, because breakpoints tell you what really needs fixing. When the product does not fit the task, users build workarounds. Those manual steps are important evidence, because they reveal where the system is forcing extra effort. At that stage, the product team may have several plausible theories, but not enough signal to know which one matters most. FDE work is meant to remove that uncertainty. After FDE starts, the picture becomes much sharper. The work shifts from guessing at the problem to isolating the part of the workflow that actually limits adoption or performance. The first gain is clarity. Once the real workflow is documented, the team can see what users actually do instead of relying on an idealized process map. From there, the highest friction point can be identified. That is the spot where small improvements matter most, because it is where time, trust, or accuracy is being lost. A narrow test keeps the intervention grounded. Instead of trying to solve everything at once, the team checks whether one focused change works in the specific context that matters. Adoption has to be measured in real use, because a polished demo can hide weak fit. Actual behavior tells you whether the change survives outside the room. That feedback loop is what makes the work valuable beyond a single customer. The field sends back evidence the product team can use to refine constraints, priorities, and design choices. The real payoff is the knowledge that comes back. Repeated edge cases, common workflow patterns, essential guardrails, and wrong assumptions all make the next product decision better than the last one. A few terms keep causing confusion around this work, and each one changes the conclusion if you use it loosely. Getting the definition straight makes the market discussion much more precise. The language matters because different words point to different measurements. If the terms slide around, the numbers and the conclusions slide with them. Labor market sizing is about counting the shape of the market, not just the headline number. 4 forward deployed engineers. That count gets messy because the same work is spread across many titles and industries. Title fragmentation is the reason a simple search misses so much. The work can look identical from the outside, but companies describe it with different labels, so the market gets split into pieces. Base compensation is the fixed part of the offer. It gives you a clean salary number, but it leaves out the pieces that can change the real value of the package. Total compensation folds in the extra pieces, and that can make two offers look closer than they really are. A package with heavy equity or bonus can sound equivalent on paper, even when the risk and certainty are very different. Job posting methodology matters because the counting rule changes the answer. Search too narrowly and you miss nearby titles. Search too broadly and you pull in roles that do not really belong in the comparison. Those distinctions are not academic details. They're the reason the discussion gets tangled. One title misses part of the market, total compensation hides uncertainty, and a posting can blur fieldwork, product engineering, and customer support into one role. That fragmentation is exactly why the job market angle belongs in discovery. Employers hire across different titles because they need one person who can connect deployment, workflow, and product learning in the same seat. A regulated workflow changes how discovery works because speed alone is not enough. The real goal is to find a solution that fits the process, the evidence trail, and the people who have to trust it. A team like this is often under pressure to turn long conversations into something usable very quickly. That sounds like a summarization problem at first, but the workflow around the summary matters just as much as the summary itself. That request captures the surface need, and it is useful because it gives us a starting point. The discovery work begins when we ask what the analyst actually needs to decide, not just what sounds efficient. The first move is to watch the work happen. By following the analyst, the compliance reviewer, and the onboarding specialist, the FDE learns where the real friction lives instead of guessing from a feature request. That observation usually exposes three different needs. One person needs decision-ready fields, another needs proof for every statement, and a third is already patching the process by hand because the edge cases keep breaking the old flow. Once those needs are visible, the shape of the solution changes. A free-form summary is too vague for review, so the better fit is a structured extraction flow that cites the source moments and hands uncertain cases to a person. From there, the work becomes testable. The team can build something narrow, try it on real examples, and measure whether it helps the people who actually use it. A narrow prototype keeps the scope small enough to learn quickly. It is not meant to solve every onboarding case. It is meant to prove whether the chosen approach fits the workflow. Real cases matter because regulated work is full of edge conditions. A polished demo can hide problems that show up immediately when the team uses actual calls and actual documents. Adoption is not just whether the model sounds good. It is whether analysts rely on it, whether review gets faster, and whether ambiguous situations still get routed correctly to a human. That measurement turns one project into reusable product learning. In this environment, a constrained extract and review pattern is more dependable than open-ended generation, so the team can carry that lesson into the next workflow. That is the discovery first shape in a regulated account. Learn the process, identify the breakpoint, introduce a focused intervention, verify the result, and then reuse the pattern when it fits. This part explains why the role gets defined so differently from one company to another and what employers are really trying to measure when they hire for it. The hiring process makes more sense once you see that the job is about reducing uncertainty in real customer work. The job is not about sitting in meetings and repeating company language. Employers want someone who can go into an ambiguous customer setting, figure out what is actually happening, and bring that evidence back so the product improves. That is why the job posting can look inconsistent from one company to the next. One team cares most about empathy, another about systems, another about deployment, but all of them are trying to hire someone who can take a messy workflow, identify the fragile point, and make it dependable. Once you can explain why the market uses so many titles, you can also explain the role's purpose in practical terms. Companies need people who can see the workflow as it really works, not as an idealized diagram says it works, and that is what turns discovery into a useful job. This part turns the earlier examples into a working habit. Start from the person doing the work, find where the break actually happens, and prove the smallest fix before you spend time on full production code. The first move is to understand the workflow from the worker's point of view, because that reveals where friction really lives. Once the break is mapped, the best next step is a small test that can show value quickly without overbuilding. Discovery first means evidence comes before commitment. The point is to learn enough from the field to know what deserves engineering time. That is why this is an operating rule, not a slogan. Careful observation leads to a focused deployment, and the real question becomes how small the first version can be while still proving the workflow is worth changing. Scoping the MVP under ambiguity means choosing a first slice of work when the problem is still fuzzy, incomplete, and changing. The hard part is not writing more requirements. It is deciding what can be built and validated before the unknowns grow into wasted effort. That shift matters because a forward-deployed engineer is supposed to turn a vague customer problem into something concrete enough to ship and learn from. If the scope stays loose, the work expands without producing real traction. When the scope is tight, the team can prove value quickly and adjust with evidence. The practical move is to carve out one narrow slice that can be finished, tested, and discussed with the customer in a short cycle. You do not remove the ambiguity first. You make the ambiguity visible, then choose the smallest piece that can answer the most important question. Scoping starts with one question. What is the smallest problem worth solving first? That matters because a small, clear target makes it possible to learn quickly from real field use instead of getting lost in a huge spec. A good scope names three things: the problem, the signal that it helped, and the boundary of what stays out for now. That keeps the work honest, because the team is aiming for learning in the field, not for a polished document that looks complete on paper. When the request is broad, narrow your attention to the place where work actually breaks down. A vague ask like using AI for support is too large to act on, but a specific bottleneck like searching policy documents during refund disputes gives you a buildable target with a clear outcome. That gravel road image is doing a lot of work. The old process is messy, manual, and full of exceptions, while the new one should be a dependable lane through one painful step. The goal is not total automation. The goal is a repeatable change that is safe enough to use every day and measurable enough to trust. A clear scope template keeps the first customer conversation focused on a real business problem instead of an open-ended demo. It gives you a structure you can reuse, then tighten as you learn more from the client. The point here is speed and clarity, not polish. The same document can stay alive through the early engagement, so the scope gets sharper instead of drifting into vague promises. The first line names the client and the problem area, so everyone knows what the document is about. The rest of the template forces 4 decisions: what the problem really is, how success will be measured, what you will do in the first 2 weeks, and what you will deliberately leave out. The final 2 sections matter because real MVP work depends on the available data and the risks that could stop delivery. That structure protects the engagement in 3 ways. It keeps the problem grounded in the customer's words, which avoids building a fancy technical demo that does not solve the business need. It gives you a measurable finish line, and it creates a boundary against scope creep by making the exclusions explicit. A field prototype can be rough around the edges, but a deployment that people rely on needs controls. Authentication, logging, retries, privacy boundaries, a repeatable deployment process, and a handoff runbook turn a useful pilot into something the business can safely operate after the FD steps away. A concrete client example shows how a vague business request becomes a buildable AI project. The goal here is to turn a broad idea into a scope problem with a clear success measure and real constraints. A request like that sounds useful, but it still leaves too many decisions open. You do not yet know which cases matter, who uses the system, or what a good result looks like, so the team cannot design against it. The useful move is to narrow the work until it can be tested. Once the problem, metric, and boundaries are explicit, the team can estimate effort, choose data sources, and avoid building extra features too early. The problem statement names the exact pain point. Coordinators spend time interpreting messages before they can answer customers. The success metric ties the pilot to a measurable reduction in triage time, while the in-scope list keeps the work small enough for 2 weeks, and the out-of-scope list prevents the project from spreading into automation, platform work, or company-wide rollout. That combination makes the project real. Specific scope lets the team build a first version, measure whether it helps, and keep the discussion focused on evidence instead of feature creep. This contrast shows the difference between a messy manual process and a workflow that can actually improve. The important question is not just what the FDE built, but how the work changed once the team had a narrow problem, a repeatable process, and feedback from real use. At the start, the process depended on people stitching together scattered information. That usually means slower work, more variation between coordinators, and more uncertainty about whether a decision is consistent or repeatable. Once the FD stepped in, the goal shifted from coping with noise to shaping a small system that could be used every day. The changes are easier to understand if we break them into the handoff, the workflow, the measurement, and the learning loop. The first move was to find a single place where time kept leaking out. That matters because automation works best when it starts with a specific bottleneck instead of trying to fix the whole process at once. From that point, the team built a small chain of steps around the handoff. The system gathers the needed information, sorts it, proposes an answer, and still leaves a person in charge of the final judgment. The team did not judge success by feel alone. They watched whether coordinators accepted the suggestion, how often they changed it, and whether the overall work got faster, because those are the signals that show real adoption. That usage data fed back into the product team. It showed which labels stayed stable, which documents were actually useful, and where the model needed more context, so the system could get sharper instead of just being deployed once. The real value is the loop that comes back from production. A small automation can save time right away, but it also teaches the team where the process is fragile and that knowledge is what makes the next version better. An FDE scope reaches beyond conversation and into the parts of the system that make the idea real. The important question is not just what the customer wants, but what pieces of code, data, process, and infrastructure have to change for that request to work. A good scope statement usually reveals the technical shape of the effort. It connects the business goal to the builder work that will actually produce a usable result. That work rarely stays in one place. It spreads across the application, the data, the deployment setup, and the operating process around it. The code layer often includes the smallest useful version of the product, plus the logic that shapes prompts, measures quality, and moves work between steps. Those pieces let the prototype behave like a system instead of a demo. Data work matters because the prototype needs real examples to test against. Sample records, labels, and extracted fields show whether the idea holds up on the kinds of inputs the customer actually has. Infrastructure defines where the work can run and what it can connect to. Even a small prototype needs a safe environment, a place to deploy, and a reliable path into external systems. Workflow design turns a technical output into an operational process. Someone has to review results. Some cases need escalation, and exceptions need a clear path instead of getting lost. Security constraints can decide what is possible at all. Access rules, masking, and production data policies shape both the prototype design and the customer's trust in it. Handoff is the part that keeps the work useful after the engagement. Clear documentation, a runbook, and a short list of open questions make it easier for the product or platform team to continue. That span is what makes the role different from a purely customer-facing engineer. The scope has to respect both the product decision and the technical reality, and scoping is where those two concerns meet. A small MVP only helps when the boundary is real, not arbitrary. The checks here make sure the slice is narrow enough to learn from, but still useful enough to matter. A practical scope needs more than enthusiasm. It needs a few pressure tests. These checks tell you whether the work is understandable, measurable, and realistic in the time available. The first test is clarity. If one person cannot explain the idea quickly, the slice still contains too much. The second test is learning. Even a failed experiment should teach you something useful. The third test is dependency control. If delivery requires a later redesign, the slice is no longer honest about the effort. That same discipline shows up in hiring. A strong candidate can choose work that demonstrates value and still leaves the system clean enough to support later, which says a lot about judgment as well as speed. The useful habit here is to narrow a vague request until the work becomes concrete enough to plan. That matters because once you have one team, one break in the workflow, and one measurable result, the problem stops being abstract and starts being manageable. A broad request tempts people to chase every possible feature or workaround, but that usually slows the decision down. Narrowing it forces a choice. Who owns it, where the process fails, and how you will know the change helped. That small slice is useful because it creates a fast, testable answer, not a permanent promise. The harder question comes after the pilot works. If the quick patch solves the issue, you need a plan for turning it into something stable instead of leaving it as a temporary workaround. A lot of real AI work comes down to deciding whether speed is buying you a useful bridge or a future maintenance problem. The point here is to separate temporary relief from a change that can actually survive production. The tension is rarely about whether the team should move quickly. It is about whether the quick move still leaves room for a durable system afterward, or whether it quietly becomes the new normal. That rule is the practical test. A shortcut is fine when it helps you learn and still leaves the architecture clean enough to improve later. Once the shortcut starts acting like core infrastructure, the work has shifted to a real fix. In enterprise AI, the line blurs fast because many temporary moves feel productive. A manual review, a prompt adjustment, or a one-off integration can get a pilot across the line, but a real deployment also needs workflow design, evaluation gates, and clear ownership after handoff. When someone pushes for speed, the deeper request is usually about risk. They want to know whether they can prove value, delay a large investment, or avoid getting trapped in endless redesign. Those requests usually hide one of a few practical worries. The client may need internal support, may want to postpone platform cost, or may be trying to stop the team from disappearing into architecture work before the use case is proven. Often the real pressure is political. If the team cannot show progress quickly, the project can lose attention before it has a fair chance to mature. Sometimes the client is being cautious with budget. They do not want to build a large platform until there is enough evidence that the workflow is worth scaling. And sometimes speed is really about escape from indecision. A temporary approach can stop the team from polishing the design forever when the next step should be learning from actual use. Those concerns are valid. So the mistake is not the shortcut itself. The mistake is agreeing to it without saying who owns the work after the pilot and what each path is optimized to prove. A pilot often looks weak when the real problem is the system around the model. The deployment includes prompts, tools, data access, guardrails, monitoring, and the workflow that turns an output into an action. A concrete example makes the trade-off easier to see. A quick path can get a team moving, but the question is whether that path stays a temporary road or turns into a production highway without the engineering work behind it. A support team can reach a demo fast by connecting the model to a knowledge base and having a human approve each reply. That gets the idea in front of users, but it is still a rough route rather than a finished operating model. Once the pilot is useful, expectations change quickly. People stop treating it like a trial and start depending on it, which means the quality and control requirements rise with the usage. At that point, the decision is no longer about getting a demo to function. It is about whether the workflow can be trusted repeatedly by many users under real operating pressure. Rare edge cases matter because they are the ones that create surprise failures. A system can look fine in common cases and still break badly when the unusual ticket or policy question appears. The human escape hatch has to be simple. If agents cannot take back control cleanly, the AI starts slowing them down instead of helping them. Data handling is part of the decision, not an afterthought. The team needs to know exactly what information the model can see and whether that access is appropriate. Logging turns a fragile pilot into something you can improve. Without reviewable errors, the team cannot tell whether problems are isolated or structural. Ownership matters because policy changes are inevitable. If nobody knows who updates the system, the workflow may keep running with stale rules long after the business has moved on. That is the real FDE contribution, stopping a temporary setup from becoming permanent by accident. A bridge is useful only when everyone knows what it leads to. The best client conversation does not force a yes or no answer. It lays out what the shortcut buys, what it risks, and what the smallest responsible version of the future looks like. That framing keeps the discussion honest. Instead of arguing against speed, you show how to keep speed while protecting the next stage of the system. Different groups care about different outcomes. If the FD ignores those incentives, the team may win a meeting and still fail to land a working deployment. Good language helps because it keeps the client involved in the decision. A strong response does not shut the request down. It makes the trade-off visible enough for the client to own it. The first script protects the pilot while keeping expectations honest. It says the fast route is acceptable, but it should be treated as exploratory, not as proof that production is solved. The second script makes the hidden expense explicit. A shortcut can work, but someone will still absorb the ongoing manual effort, and that cost belongs in the decision. The third script adds discipline. If the team knows who owns the follow-up and what metric decides whether the patch survives, the temporary choice stays temporary. That is why the wording works. The goal is not to declare the best answer from above, but to make the consequences easy for the client to weigh. A useful way to keep the discussion concrete is to track the story of the work from start to finish. First, identify what was broken, then what changed, then what learning came back from production use. Those three questions keep the conversation grounded in evidence rather than opinion. They force the team to talk about the original problem, the actual intervention, and the result that came back. Once those questions are on the board, everyone has the same frame. The conversation stops being vague and starts becoming a traceable chain from problem to fix to learning. A concrete example helps the pattern stick. The details matter because they show how a pilot can create both value and useful design knowledge. The starting point is a familiar failure mode. The team had speed, but not consistency, so the process could not be trusted for policy-sensitive work. The change is not just a prompt tweak. It is a workflow redesign. The model does the first pass. The human keeps final control, and risky cases are diverted before they cause trouble. The measurement also shifts the conversation. Instead of judging the system only by model quality, the team watches how people use it, how much editing it creates, and how often problems escalate. That final outcome is the real payoff. The pilot gives the organization specific evidence about content gaps, unsafe phrasing, and workflow boundaries that the next version can build on. A pilot is not only successful when it ships. It is successful when it teaches the product or platform team something durable that can guide the next build. A decision table helps when the room is tense because it turns opinion into comparison. It gives everyone a shared way to judge speed against durability. The contrast is straightforward. The quick patch is for unblocking and learning, while the long-term fix is for repeatability, ownership, and scale. The trade-off is speed now versus stability later. That kind of artifact is useful in a hard client conversation. Once the options are visible, the discussion becomes a choice about priorities instead of a vague argument about taste. This tension also shows what the FD role really reaches into. The work is not only persuasion. It touches the actual system boundary where the prototype becomes part of the client's environment. The builder may be making changes in several layers at once. That includes the code path, the data sources, the hosting choice, the approval flow, the security rules, and the documentation that hands the work off cleanly. On the code side, the work can be small but important. Wiring calls, retries, orchestration, and logging are often what make the prototype dependable enough to test. On the data side, the choice of sources matters as much as the model choice. If the system sees the wrong records or unapproved content, the output can look polished and still be wrong. Infrastructure shapes what kind of system you actually have. A notebook demo and a secure service may both work, but they imply very different levels of reliability, access, and support. Workflow design decides where the human stays in the loop. Approval steps, exception paths, and escalation rules keep the AI from acting beyond the team's comfort level. Security work is part of the deployment decision too. Access control, masking, and rules about whether production data can appear in the pilot all affect whether the system is acceptable to run. Handoff is where the temporary work becomes legible to the next owner. Good documentation says what was built, what still breaks, and who is responsible for the next step. That mix is what separates the role from adjacent ones. The FD is close enough to implementation to touch the real system, but still close enough to the customer to understand the operating context. A product manager is usually closer to the strategic decision about what should exist and why it matters. That work shapes direction more than it shapes the prototype mechanics. A solution engineer is often strongest at showing feasibility and reducing doubt. The emphasis is on possibility, confidence, and helping the customer believe the idea can work. An FD sits right where the prototype meets the messy operating environment. That position makes the role unusually responsible for turning a promising demo into something the customer can actually run. Ownership is the tricky part. If the FD absorbs too much long-term platform responsibility, the pilot can look polished but become brittle later. If the FD avoids the operational details, the pilot may never become real. Deployment decisions depend on more than picking a model. The important shift is from intuition to evaluation. Test cases, observe behavior, and the constraints of the actual use case. That means the team judges the system by how it behaves on the tasks that matter, for the users that matter, under the constraints that matter. The model style matters less than the evidence it produces. A shortcut has to be judged against the testing plan, not just against calendar time. If it blocks error tracing, comparison, or measurement, it may cost more than it saves. Agent workflows raise the stakes because the system can act on behalf of a user. The boundaries around tool use, approval steps, human deferral, and uncertainty handling are what keeps speed from turning into an incident. The argument feels personal because each group is optimizing for something different. Once you name those incentives, The disagreement looks less like conflict and more like competing definitions of success. People are not usually disagreeing about the same goal. They are each carrying a different risk, and that makes the conversation feel sharper than it really is. The founder is looking for movement because momentum keeps the project alive and keeps others invested in it. The client team wants something they can actually work with right away. Usefulness now is often more persuasive than elegance later. The FD is thinking about whether the design will hold up once real users, real data, and real exceptions arrive. The platform or security team cares about whether the approach can be maintained, governed, and supported without creating hidden risk. Product teams want more than a one-off success. They want the pilot to teach them something they can apply to the next version. A good compromise often has expiration conditions. The patch can be used now, but only if the team agrees on what to measure and when responsibility changes hands. That is not hesitation. It is a controlled sequence. Learn quickly, keep the future open, and make sure the temporary choice does not quietly become permanent. Employers value people who can speak both the language of demos and the language of deployment. They want someone who can move quickly without losing the path to a maintainable system. That is why trade-off fluency matters in hiring. Candidates who can set expectations clearly, explain costs diplomatically, and preserve a route to production are easier to trust with customer-facing AI work. A simple conversation pattern helps when the client wants the shortcut. It keeps the response structured and keeps the decision shared. First, make the benefit of the fast path explicit. Then name the cost of skipping the structural fix. Finish by giving a choice that preserves ownership and measurement. The order matters because it keeps the conversation balanced. People can accept a shortcut when they understand exactly what it buys and what it postpones. That approach does not block the client. It helps them decide whether they need speed as a temporary bridge or speed as part of a durable system. Once that choice is clear, the discussion usually shifts to the human/AI boundary itself. The remaining design problem is not just patch versus rebuild, but how much human control the workflow should keep. The seam is where model capability meets human responsibility, and that boundary is what decides whether an AI system survives real production. The focus here is how to draw that line, so the workflow stays useful, safe, and operable. The goal is to turn instinct into a repeatable method. When the seam is designed well, the system stops being a pile of demos and starts behaving like something an enterprise can trust. The important design question is not whether the model can answer. It is which workflow step can be automated, which step must stay with a person, and which step needs review before anything downstream changes. A left-to-right flow with clear tags makes the boundary obvious. Once the steps and handoffs are visible, it becomes much easier to reason about control, accountability, and feedback from production. The method is meant to work across many deployments, not just one customer problem. Each step narrows the system from a vague use case into a controlled workflow with clear ownership. The sequence starts with how people already work and ends with what the organization learned from the rollout. That keeps the design grounded in process, evidence, and adoption instead of just model behavior. Start from the actual path people follow: intake, triage, retrieval, drafting, approval, logging, escalation, and follow-up. If the workflow is designed around a prompt instead of around those steps, the system tends to break where real work is messy. Once the workflow is mapped, assign responsibility to every step. Those labels make it clear where the model can act alone, where a person must do the work, and where the machine can assist but not release on its own. Agent-led means the system can complete the step automatically. That works best for repeatable tasks with low judgment risk, like extraction, classification, or drafting a routine response. Human required means the step belongs to a person, not because automation is impossible, but because accountability or expertise has to stay with the human. That is where final decisions, licensed actions, or sensitive judgments stay anchored. Human review sits between those two. The AI can prepare the action, but a person has to inspect it before release, especially when the downstream impact is significant or a mistake would be costly. Progress should depend on evidence, not on the model sounding certain. A strong workflow uses retrieved policy text, validated fields, threshold checks, or second-pass review as the gate for moving ahead. The SEAM has to survive ambiguity, missing data, adversarial input, and silent failure. If a synonym, a missing field, or a borderline case breaks the process, the design is too fragile for production. In regulated settings, workflow control is also governance. The more the AI influences eligibility, diagnosis, denial, pricing, or escalation, the more carefully suggestion must be separated from decision. The handoff has to be measurable. Cycle time, error rate, escalation rate, reviewer load, adoption, and independence from the embedded team all tell you whether the SEAM is actually working. A good SEAM does more than solve one customer problem. It produces reusable knowledge about what should become a pattern, what should become platform work, and what should never be repeated as a one-off fix. The abstract steps become much easier to judge once they are placed in a concrete business process. A specific example makes the responsibility split and the evidence gates much easier to see. Insurance underwriting is a good test case because speed matters, but decisions still need control and traceability. The SEAM has to remove clerical load without pushing judgment into the wrong place. In a messy intake process, underwriters often spend their time cleaning up submissions before they can even use their expertise. The real opportunity is to automate the sorting work so human judgment is spent on the cases that actually need it. The redesign turns that intake into a control workflow. Each stage gets a clear owner, a clear machine role, and a clear handoff rule. The table shows the SEAM in action. Routine extraction and logging can be automated, borderline eligibility gets human inspection, and final pricing decisions stay with a licensed underwriter. The old process wastes expert attention on formatting and reconciliation, which delays every decision behind it. The customer feels that delay as waiting, and the business feels it as inefficiency. What changes is the system around the model, not just the model prompt. Parsing, normalization, retrieval, orchestration, validation, and a review interface all shape whether the recommendation is trustworthy and usable. Production success shows up in usage and control, not in a polished demo. If underwriters accept the flow, exceptions move faster, missing data bounce-backs drop, and every decision can be traced, the SIEM is doing real work. The learning loop matters because repeated failures often reveal a deeper pattern. If most of the pain comes from inconsistent formatting, that should become a reusable intake component rather than a one-off customer repair. Healthcare triage raises the stakes, so the SIEM has to be stricter. The design still helps with routing and administration, but it has to stop well short of improvising clinical judgment. A patient portal can classify messages and sort them into the right channel, but that sorting must not become medical advice. The safer pattern is to assist with routing while keeping clinical authority outside the model. The point is to separate administrative acceleration from clinical decision-making. Once that boundary is clear, each message type can be handled with the right level of oversight. The machine can sort the message, pull out symptoms, and prepare a routing suggestion. That saves time and reduces manual triage work without giving the system authority to make the clinical call. A nurse should inspect anything that depends on symptoms before it enters the clinical queue. That review step keeps the routing useful without letting the model drift into clinical judgment. Urgent cases need a licensed clinician or an emergency path immediately. No automation layer should slow that down or reinterpret the risk. Administrative summarization can still be automated if policy allows it. That is a good use of the model because it speeds documentation without changing the clinical decision itself. Clinical advice stays with a qualified professional. That boundary is the difference between helpful support and unsafe overreach. The SIEM has two jobs at once. It removes administrative friction, and it prevents the model from stepping into territory where judgment must stay human. In a high-stakes workflow, both of those goals matter equally. These terms point to different layers of the same system. Architecture is the full arrangement around the model. Workflow design assigns responsibility. Eval-driven deployment checks behavior before release. And reliability and governance keep the system explainable and controlled. The practical part of the role is that it crosses layers instead of living in only one of them. The work reaches from code and data all the way through security, workflow, and handoff. That builder mindset is what separates the role from pure consulting. The FD is not only advising. The FD is often shaping the actual system that will run in production. Code work includes the glue that connects systems, the retrieval layer, the validators, the parsers, the routing rules, and the evaluation harnesses. Those pieces make the workflow behave consistently instead of depending on luck. Data work is about choosing the right sources, cleaning schemas, and building examples that show both success and failure. Without that foundation, evaluation and improvement stay vague. Infrastructure is what makes the system safe to operate. Access control, observability, environment separation, deployment paths, and rollback options all determine whether the workflow can be trusted after launch. Workflow design decides visibility, intervention points, escalation, and logging. That is where the human/AI seam becomes a concrete operating rule instead of a vague intention. Security is part of the seam because the workflow only stays safe if permissions, redaction, and secret handling are controlled from start. Least privilege limits how far mistakes can travel. Handoff matters because the customer has to end up owning the system. If the workflow cannot run without the embedded team, then the seam was never fully designed. That sentence is the real test of maturity. A working seam leaves behind a process the customer can operate, not a dependency on permanent outside help. Before calling the design finished, it helps to pressure test the weak spots directly. The questions below expose whether the workflow is truly controlled or only looks good in a happy path. These questions force the team to think about failure, uncertainty, safety, evidence, and ownership. If any one of them is unclear, the deployment is not ready for broad use. Start with the worst plausible error because that reveals the real risk surface. If the bad answer would cause major harm, the system needs stronger controls or a narrower scope. Uncertainty has to lead somewhere concrete. The workflow should know when to defer, ask for more evidence, or hand the case to a person. Regulation often changes the answer, even when the technical capability looks fine. Some steps should stay human because the control requirement matters more than the automation opportunity. Review only works when the reviewer has enough context to decide well. The system should surface the exact evidence that supports the recommendation, not just the recommendation itself. Ownership is a practical test of good design. If the answer depends on a permanent custom support layer, the system may function, but it is not yet truly transferable. Vagueness is a warning sign, not a minor detail. A seam that cannot answer those questions cleanly is still too risky to put in front of real users. That same discipline shows up in hiring. Teams want people who can move between product, workflow, and governance while still keeping the engineering side precise and measurable. The practical rule is to let the model accelerate routine work, keep human accountability where judgment matters, and turn every exception into organizational learning. Framed that way, the architecture, the workflow, and the governance all point in the same direction. Once the consequences are regulated, the seam has to meet a higher standard. The same design ideas still apply, but the bar for control and review rises sharply. Governance and safety become central when a system is used in a regulated setting, because decisions must be explainable, controlled, and defensible. The focus here is on the rules, checks, and accountability needed before such a system can be trusted in production. Healthcare, government, and finance change what good AI deployment means. The real question is no longer whether the model can produce an answer, but whether the whole workflow can survive scrutiny, oversight, and later review. In these settings, the buyer wants proof, not just performance. They need to defend decisions after the fact, so the system has to leave a clear trail and keep a person in the loop where judgment matters. That shifts the FDE's work beyond model quality. A system can be useful and still fail the practical test if it cannot be reviewed, trusted, and handed off cleanly. The regulated customer brings a wider set of requirements, and that changes how the rollout is judged. The deployment still has to create value, but it also has to clear control and compliance checks before it becomes normal business practice. A fast pilot is not enough when the environment is regulated. The workflow has to pass security, privacy, legal, access, logging, and approval review before anyone treats it as real infrastructure. Security review asks who can reach the system, what they can do, and whether the integration opens any unsafe paths. That is usually one of the first gates before real use. Privacy review checks what data enters the workflow and whether sensitive information is exposed, retained, or reused in ways the organization cannot justify. Legal and compliance review ask whether the workflow fits policy, regulation, and contractual obligations. A model can be technically fine and still be unusable if it violates those constraints. Access control is about least privilege. Only the right people and systems should be able to see data, invoke tools, or change the workflow. Audit logging review makes sure the system can be reconstructed later. If something goes wrong, the organization needs timestamps, inputs, outputs, and edits, not guesses. Human approval design decides where a person must review, approve, or override the model. In regulated work, that checkpoint is part of the control system, not a nice-to-have. Production monitoring sign-off means the customer has a plan for watching the system after launch. It has to be monitored by the people who will own it, not just by the team that built it. Those reviews are the bridge between a pilot and day-to-day use. They are how the organization decides that the workflow is controlled enough to live inside standard operations. The vocabulary matters here because these terms shape how teams design and approve the system. Getting them precise avoids a lot of confusion later. An audit trail is the record that lets someone replay the story of the workflow. It should show what entered the system, what came out, who touched it, and what version was running. Human in the loop means the model does not get the final word on its own. A person has to inspect the output before it becomes a real decision or record. The deployment lifecycle is the full journey, not just launch day. It covers how an idea gets tested, approved, operated, watched, and eventually replaced when it no longer fits. Handoff is when ownership shifts to the customer team. The system should be stable enough, documented enough, and understandable enough that they can keep it running without constant help. LLM application architecture is the full shape of the system around the model. The model is only one part. The rest is how users interact with it, how requests move, where data lives, and how permissions are enforced. Human/AI workflow design is about dividing labor carefully. The important question is which steps can be automated and which steps must stay with a person so the process remains safe and usable. Eval-driven deployment means the rollout is governed by evidence. Reproducible tests and clear acceptance criteria tell the team whether the workflow is ready to expand. Agent reliability and governance become critical once the system can take actions over several steps. The controls have to keep those actions predictable, bounded, and traceable. That is the real shift in the role. The work stops being about a single successful demo and becomes about building something the organization can rely on repeatedly. A hospital-adjacent workflow makes the constraints very concrete. The useful part is not just the draft the model produces, but the guardrails around how that draft is used. A draft summary assistant can save real time because it turns scattered notes into something staff can act on quickly. The first version often looks promising because it reduces clerical effort and speeds up intake. The risk is that a polished mistake looks trustworthy. In a clinical setting, that kind of error can affect care, routing, and the people who receive the note next. The early pilot usually has useful behavior but weak control. The technical demo may impress people while still leaving important operational gaps. Without a clear audit trail, nobody can reconstruct who edited the output or how it moved through the workflow. That makes review and incident response much harder. Inconsistent handling of uncertainty means the model can look confident even when it should be flagged or deferred. That is dangerous because staff start treating every answer the same way. A smooth answer can create false confidence. If the output looks finished, people stop checking whether it is actually reliable. If the human review step is not documented, it is easy for the workflow to skip the very checkpoint that keeps the system safe. In regulated work, that step has to be explicit. A vague data boundary is a serious problem because patient information cannot float loosely between systems and people. The team has to know exactly what enters the model and what stays out. Once the FDE starts shaping the system, the workflow becomes narrower, clearer, and easier to govern. The changes are not cosmetic. They alter how the work is allowed to happen. The fix is to separate drafting from authority and to make every checkpoint visible. Once the review path, logging, fallback behavior, and success metrics are built in, the workflow becomes something the organization can actually supervise. That before and after difference is the heart of regulated FDE work. The model still matters, but the bigger job is designing the surrounding process, so oversight is built in from start. The job reaches across the full stack, not just the model endpoint. In regulated accounts, the FDE ends up working in code, data, infrastructure, workflow, and security at the same time. A regulated workflow is a system problem. One person often has to connect technical details to operational policy because changes in one layer affect all the others. On the code side, the work is about making the system behave predictably under real conditions. Integration, routing, testing, and failure handling all matter because they determine whether the workflow degrades safely. Data handling is just as important. The team has to decide what the model may see, what must be removed, what could be retained, and what should never enter the system at all. Infrastructure defines the safety perimeter. Access control, secret handling, and environment boundaries make sure the workflow stays inside the right operational box. Workflow design decides how work moves from user to model to person. That path has to be deliberate, especially when exceptions need to jump to a human quickly. Security work includes the controls that keep the deployment acceptable to the customer's own standards. Least privilege, vendor review, and internal approvals are part of making the system usable in a real organization. Handoff is what makes the customer independent. Good documentation, runbooks, and training let the customer team operate the system without depending on the original builders for every exception. That breadth is why the role can feel more like systems engineering than pure ML work. The FD has to coordinate technical choices with legal, security, product, and operations concerns in the same week. The life cycle matters because a deployment is not a single event. It is a sequence of stages, and regulated work puts pressure on each one. The term deployment gets used loosely, so it helps to break it into stages. That makes it easier to see what the FD has to build at each point. The sequence starts with a narrow prototype, then a limited pilot, then a controlled production transition, and finally normal production use. After that come monitoring and iteration, and eventually retirement if the system no longer fits the job. A prototype can be exciting and still unsafe. Production has the opposite requirement. It should fail in known ways, log clearly, and keep human intervention possible at every critical step. The practical contrast is easiest to see as a before and after story. The early version may prove the idea. The FDE version proves the workflow can operate safely. The table makes the shift visible. The goal moves from a clever demo to a system that can be repeated, audited, and owned by the customer. That is the practical gap to keep in mind. The organization needs to know what breaks, who catches it, and how lessons from each exception feed back into the workflow. Audit trails can seem like background plumbing until the first incident. Then they become the record that turns confusion into something the organization can examine and explain. The value of an audit trail shows up when a decision needs to be checked. Without it, a problem becomes much harder to investigate and much harder to defend. At minimum, the record should show what entered the workflow, what the model produced, what a person changed, who approved it, and when it happened. In some cases, version information for the model or prompt logic matters too. The real design goal is reconstruction. The workflow should be able to explain who touched the output, what changed, and whether the model was uncertain at the time. That question matters because the first reviewer often shapes what happens next. In regulated work, sequence and responsibility both need to be visible. Approval is a control point, so the organization has to know exactly which person signed off. That becomes important for accountability and later review. Edits matter because the final result may differ from the model output in important ways. The audit trail needs to preserve that difference. Uncertainty should not disappear into the background. The workflow needs a defined response, such as escalation, refusal, or human review. If the path cannot be recreated, the system is not really auditable. Reproducibility is what makes oversight possible. Long review cycles are not just delays to work around. They're part of how the customer decides whether the workflow is safe enough to live in their environment. The safest rollouts lean on repeatable evaluations, not gut feeling. That is how the team proves the workflow stays inside the rules that matter. Evaluations turn the rollout into something measurable. The team can compare behavior against concrete cases instead of relying on a vague sense that the model looks good. A good test set mirrors the actual work, not just the easy cases. It should include routine, ambiguous, risky, and policy-sensitive examples. Routine cases check that the system handles the common path efficiently. They're the baseline for whether the workflow is useful at all. Ambiguous cases test the handoff between model and person. The right behavior is often not a perfect answer, but a correct escalation to review. Dangerous edge cases check whether the system knows when not to act. Refusal or deferral is often the safe outcome. Formatting cases matter because regulated workflows often depend on exact structure. Even a correct answer can fail if it does not fit the required form. Policy cases check whether the model stays inside approved limits. That is how the team protects against answers that sound fine, but cross a line the customer cannot accept. The center of gravity shifts from general quality to constraint compliance. The team wants to know whether the workflow behaves safely under the rules of the account. Customer fear is usually about losing control, not just about accuracy. The answer has to preserve human accountability for decisions with clinical, financial, or legal weight. A simple test harness is enough to show the pattern. The syntax matters less than the habit of checking behavior against known constraints before the rollout expands. The loop is simple on purpose. It loads cases, runs the agent, checks the output against the expected constraints, and then groups failures so the team can see where the workflow is weak. The habit matters more than the tool. Before a broader launch, the team wants evidence that the workflow behaves the way this regulated environment requires. The handoff between person and model changes meaning here. It is no longer just division of labor. It is one of the main controls that keeps the system safe. In earlier work, that scene was mostly about speed and convenience. In regulated work, It decides where authority lives and how risk is contained. The good pattern is pretty consistent. It limits what the model can decide, makes uncertainty visible, and gives the reviewer the evidence needed to make a real judgment. The model should be allowed to draft, classify, summarize, or route, but not make silent final decisions where judgment matters. When confidence drops or policy is unclear, the system should flag that clearly, and the reviewer should see the evidence, not just the polished answer. That is why agent reliability becomes a business issue. Once an agent can read, decide, and act across several steps, missing controls turn convenience into liability. The clearest way to understand the shift is to compare the fragile demo with the supervised system. The differences show up in review, security, logging, and ownership. A useful comparison starts with a few simple questions. They show what was broken, what changed, how adoption was measured, and what the team learned. That question identifies the original failure mode. Usually the answer is not that the model was useless, but that the workflow lacked the controls needed for real use. This gets at the actual engineering work. The answer should show concrete changes in code, data handling, workflow design, and governance. Adoption in a regulated setting is not just usage. The team needs to know whether the system is being used safely, repeatedly, and under monitored conditions. The workflow should teach the team something specific about reliability and fit. Good learning comes from failure modes, not just from praise. The hospital case makes the pattern easy to see. The before state is fragile, and the after state is a supervised workflow with clear controls. Before the redesign, the system looked good in front of people, but could not survive normal operational pressure. Speed alone was not enough. After the changes, the model had less authority. The review step became real, the record became traceable, and low-confidence cases had a safe exit path. Measurement also changed. The team looked at safety and operational cost, not just how many people clicked the button. The most useful learning came from limits. The team learned where the model held up, where it failed, and what kind of review process people could actually keep doing. That is the pattern worth reproducing across regulated accounts. Human judgment stays responsible for the hard calls, and the machine's role stays visible enough to supervise. There's a simple rule to keep in mind when a customer is regulated. The FD has to turn a clever prototype into a supervised system that can be trusted in operation. That is the job in one line. The system must be useful, but also has to be controllable, reviewable, and handoff ready. Readiness is not just a feeling, for things have to line up before the deployment can be considered complete. The model still has to be worth using. If it does not help enough to justify the workflow, the rest of the controls do not rescue it. The review step has to be visible and realistic for the people doing the work. A control that nobody can sustain is not really a control. Oversight depends on records that can stand up later. If the trail is weak, the organization cannot explain what happened with confidence. Handoff has to be real. The customer team should be able to operate the workflow themselves instead of depending on the FD for every change or exception. If any one of those pieces is missing, the system is not done yet. It may be promising, but it is not ready for durable use. That is why the role is valuable in the job market. The strongest FDs can lower risk without slowing the customer to a halt because they understand both product needs and governance requirements. The chapter's road image fits regulated work very well. The challenge is to make the route safe and repeatable without pretending the rough terrain was ever simple. A prototype is often usable but uneven, and it can be mistaken for something finished. The FD smooths the path by adding structure, controls, and ownership while still respecting the constraints underneath. The extra work is practical, not decorative. These are the pieces that make the system safe enough for daily operation. Access controls keep the wrong people and systems out of sensitive parts of the workflow. They define the boundary around what the system is allowed to touch. Auditability means the workflow can be examined after the fact. That matters whenever a decision may need to be defended or reconstructed. Human approvals keep final authority with a person when the stakes are high. That is part of what makes the workflow acceptable in regulated settings. Exception handling is where the system decides what to do when a usual path breaks. Good workflows route unusual cases somewhere safe instead of forcing a bad guess. Reliability tests check whether the system behaves the same way under repeated use and edge conditions. That is how the team learns whether the workflow is stable enough. Documented ownership makes it clear who runs the system, who responds to issues, and who is responsible when something changes. Without ownership, handoff never really happens. Those pieces are what turn a rough path into something the organization can use every day. The system is still a system, not magic, but now it is governed well enough to depend on. The practical lesson is that deployment means much more than launch. It means proving the workflow can be operated, inspected, explained, and transferred inside the real limits of a regulated customer. The vertical-specific details come next, where the differences between healthcare, government, and finance shape the actual implementation plan. Those field-by-field constraints decide how the generic operating rule gets applied in practice. Exit design is where an engagement stops being something only the FD can run and becomes something the customer can own. The focus is on transfer, stability, and a clean departure that leaves the system usable without constant outside help. The chapter has already covered how to scope work, run engagements, and shape safe human AI workflows. Exit design is the point where those pieces have to connect into a finish. The customer should be able to carry the work forward without the FD holding everything together. A demo working is not the finish line. The real handoff happens when the customer can operate the system, explain how it behaves, and make changes without depending on the builder for every decision. That is what moves the deployment from prototype into production and then into adoption. Teams often stop too early because the first useful result feels like success. A summary that saves time or a workflow that reduces triage is valuable, but durable value only appears when the system is embedded in operations, its failure modes are known, and someone on the customer side owns it day to day. A prototype can show that the architecture works: prompt, retrieval, model call, and user interface. What it cannot do yet is stand alone, because there is still no runbook, no training, and no clear owner to keep it moving once the FD steps back. If every small change still routes back to the FD, the customer has not received ownership. The system may be functioning, but the engagement is still attached to the builder instead of the client team. The metaphor matters because the rough path gets you moving, but it is not the same as a maintained road. Production needs grading, lane markers, and a road crew on the customer side, or else the original builders remain the only people who can safely navigate it. A clean exit leaves behind a system that is stabilized, documented, measured in use, and able to feed learning back upstream. Those 4 changes tell you the work has moved from a builder-owned prototype to something the customer can actually run. First, the rough edges get fixed. Prompts, retrieval approvals, logs, and escalation paths. Then the customer gets documentation. Adoption becomes visible through operational measures, and the product team receives the lessons, so the engagement improves future deployments instead of creating support debt. That broader role is why exit design is part of the builder's job, not an afterthought. The FD may shape retrieval, instrument prompts, wire access rules, tune latency, define failure handling, and then translate all of that into a system the client team can confidently own. A handoff checklist turns ownership into something you can verify, not just hope for. The point is to make sure the system can survive without the FD standing beside it. The version on the board is intentionally simple so the idea stays visible. It is a template for judging readiness, not a promise that the document itself is complete enough for every enterprise setting. Each line checks for a specific sign of transfer. The diagram proves the team understands the system. The runbook proves they can respond to failures. Independent deployment proves they can operate without help. And named sign-off proves responsibility has actually moved to a person who accepted it. Most handoffs fail in ordinary ways, not dramatic ones. The system may exist and even work, but the client team still does not know how to run it, recover it, or own it when something changes. That is why evidence matters more than confidence statements. A successful handoff is shown by actions the client team can perform on its own. Deploy a change, explain the runbook, and name who approves future changes. When ownership stays trapped with the FD, the engagement starts to behave like ongoing consulting instead of a finite deployment. Small fixes keep arriving. The system keeps needing one more week of help, and the original project quietly turns into a support relationship with the wrong economics. A clean handoff means the customer can keep the system running without depending on you. The goal here is to leave behind enough clarity, ownership, and support structure that nothing falls through the cracks. The handoff should cover more than just the software itself. It needs the documents, the training, the named owner, and the support plan so the customer knows what they have received. Documentation should explain how the system fits together, what it depends on, and where it can break. That gives future engineers and operators a starting point when something behaves unexpectedly. Training matters because people need to practice the workflow, not just hear about it. A live walkthrough shows whether each group can use the system confidently and ask the right questions. Responsibility has to land on a real person. When someone signs off as the owner, there is no ambiguity about who makes decisions and who gets called when action is needed. Support boundaries prevent open-ended dependence on a delivery team. The customer should know the time window, the issue types that still qualify for help, and when the handoff is fully complete. An escalation path removes confusion when the system fails. If people know who to contact and which problems are urgent, they can respond faster and avoid turning every issue into a crisis. Each part serves a different audience, but they all protect the same outcome. The documents help people inherit the workflow, the training proves they can explain it back, and the sign-off makes responsibility explicit instead of assumed. LLM deployments need the workflow itself to be handed over, not just the interface. The customer has to know where the model can be wrong, where a human must review, and if an agent is involved, what actions it may take, how those actions are logged, and what safeguards keep it within safe bounds. Before FDE involvement, the problem is usually vague and operationally messy. After FDE involvement, it becomes a system with a clear use case, a review path, and a way to reach production. At the start, people can name the pain, but they cannot yet shape it into a workflow. That gap matters because a technically feasible idea still fails if it has no boundaries, no handoff rules, and no place in the real process. Once the FD has done the work, the conversation changes from complaints to operating details. The customer should have a use case they can test, a deployment path they can follow, and a named owner who can keep it alive. A narrower use case means the team stops trying to solve everything at once. That makes evaluation possible because you can point to specific cases and ask whether the system handled them correctly. A clearer life cycle means everyone knows what happens from prototype to staging to release. It removes guesswork about who approves what, when changes are allowed, and how the system moves forward. A review point matters because not every output should go straight through. Some workflows need a person to inspect low-confidence cases, exceptions, or risky decisions before the system acts on them. A working path to production is the difference between a demo and a deployable system. It means the prototype has already been connected to the constraints, checks, and ownership needed for real use. A named owner keeps the system from depending on the FD forever. Once the handoff is complete, the customer has someone accountable for maintenance, decisions, and follow-through. That is why the work is valuable. It should make the system durable, not just bigger. A good deployment can handle the customer's actual environment, where edge cases, delays, and imperfect data show up every day. Eval-driven deployment means readiness is tied to evidence. The metrics can be simple or operational, but they have to tell you whether the system is doing the job it was meant to do before anyone relies on it at scale. That becomes even more important with an LLM application architecture, because flexibility creates ambiguity. The FD turns that ambiguity into rules about scope, escalation, data access, review, and failure handling, so the workflow itself makes the model's behavior legible. A prototype can prove the workflow works, but production has to prove it can survive real use. This part covers the extra work that turns a promising demo into something a team can trust. A field prototype often settles the main question: does the idea solve the problem? Once that answer is yes, the focus shifts to everything a real environment demands because reliability and control matter more than speed. Access has to be controlled before anyone can depend on the system. Authentication identifies who is connecting, and authorization limits what that person can do once they are inside. Once the system is running, people need a way to see what it is doing. Logs, metrics, and traces make failures visible and help you understand whether the service is healthy or drifting into trouble. Real systems fail in small ways all the time. Good error handling keeps those failures from becoming crashes, and retries give transient problems a chance to recover without human intervention. Production also needs clear limits on what data can move where. Those boundaries protect sensitive information and make it easier to explain compliance, retention, and access rules. A manual launch process is fragile and hard to repeat. A deployment pipeline gives you a controlled path from code to environment, so releases are consistent and less dependent on one person. Someone has to be able to support the system after the builder steps away. A runbook gives the next person the steps for common issues, escalation, and routine maintenance, which makes the handoff real instead of informal. Those additions are what keep the system supportable after the FDE leaves. A fast build on a laptop can prove the workflow, but it does not prove enterprise readiness. Production is the point where that workflow has to keep working under real conditions. An exit test tells you whether your work has actually transferred to the client team. It matters because a good engagement ends with independence, not with continued dependence on you. Before stepping away, use a simple check. Can the team explain it, change it, and recover from failure on their own? Those three questions reveal whether ownership has really moved. If they can explain it clearly, they understand the structure well enough to support it. If they cannot, then the system still lives mostly in your head, which is a sign that knowledge is not transferred. Being able to explain a system is not enough if no one can safely modify it. Real handoff means the team can make routine changes without waiting for you to approve every step. Failure handling is the hardest test because a system is only useful when the team can respond under pressure. If they need you every time something breaks, then they do not yet control the system. When all three answers are yes, the handoff is complete. At that point, your role has shifted from building the system to having made the team capable of running alone. If the answers are no, the issue is usually ownership rather than technical skill. A strong system that the customer cannot operate on its own still leaves the job incomplete. There is a career signal here, but should be read carefully. Teams value FDEs who can create early value and still avoid creating a permanent dependency, because that shows judgment and maturity. That rule keeps the focus on the full deployment lifecycle, not just the first successful demo. A useful intervention leaves behind a system the customer can run safely on their own. Once exit is clear, the next question is progress. How do you tell early whether the engagement is headed toward a clean handoff or a messy one? That shifts the focus from ending well to monitoring the path that gets you there. Measuring engagement means checking whether the work is still tied to the real business problem, not just whether activity is happening. That matters because a project can look healthy on the surface while quietly drifting away from the outcome it was meant to produce. The harder question is not whether the team is busy, but whether the engagement is still aimed at the right problem. By week 3, a demo can work and the customer can sound pleased, yet the original goal may already be slipping out of focus. That is the trap. A plan can feel orderly and still be wrong, incomplete, or outdated. Measuring your own engagement is a way to catch that drift early, before discipline turns into blind persistence. The real issue here is not reporting activity. It is judging whether the work is creating value. That distinction matters because busy work can look productive right up until it starts hiding a failing engagement. That is the deeper test behind progress updates. A project can move forward on paper and still fail to change anything meaningful for the customer. Technical completion is only one signal. In enterprise AI, the system may be finished while the engagement is still off target because the wrong people are involved, the workflow is clumsy, or the model is solving something low value instead of the real business problem. That is why regular self-checks matter before the work hardens into a polished mistake. They force an honest look at whether the original request still matches what the field has revealed. Schedule only tells you whether work is moving. These 3 metrics tell you whether the work is actually landing with users, staying connected to the customer, and still aimed at the right problem. A practical FDE tracks more than delivery dates. The point is to watch progress from three angles: value, engagement, and fit with reality. The first measure asks how quickly the engagement produces a real benefit for a real user. That matters because early value is the clear sign that the project is moving beyond setup and into adoption. The clock starts at the engagement, and it stops at the first visible improvement in working life. A slide deck or a lab demo does not count, because the user has not felt any change yet. In an AI project, that benefit can be small but concrete. A draft reply that speeds up a support agent, a classifier that cuts manual triage, or a suggestion that replaces a full rebuild of the workflow. Those moments prove the system is helping someone do real work. This measure keeps attention on adoption instead of internal activity. Infrastructure work, prompt tuning, and retrieval improvements all matter, but they are not enough if nobody outside the project team can point to a benefit yet. The second measure asks how often the right people on the customer side are actually involved. If they're engaged in decisions and feedback, the project stays close to the work it is meant to change. A stakeholder can be anyone with enough authority or daily contact to shape success. That includes the sponsor who approves it, the operator who uses it, the reviewer who checks it, and the manager who decides whether it survives. The frequency that matters is not meeting count for its own sake. It is the rhythm of real participation, reviewing outputs, raising friction, and helping confirm that the product still fits the workflow. When that contact drops off, is often a warning. The work may have become too technical, too slow, or too detached from day-to-day use, and silence can mean the project is drifting rather than succeeding. The third measure compares the original plan with what the team has actually learned. That comparison matters because real data often changes the shape of the problem. Scope is the boundary of what the engagement is supposed to solve. At the start, that usually means one clear use case, like summarizing tickets, routing requests, or extracting fields. Once the system meets actual behavior, the original guess may turn out to be incomplete. A model issue can be a data quality issue. A simple feature can require human review, and something that looked valuable can end up barely used. That is a better question than whether the team is still following the first plan. The goal is to keep aiming at the most useful thing the evidence is pointing to, not just the thing that was written down at the beginning. That habit of revisiting the problem is what keeps the engagement honest. It is the point where delivery becomes learning, and learning changes the direction of delivery. A clean schedule does not guarantee a correct outcome. If the team is marching toward the wrong target, the plan can look healthy all the way to the end. This contrast captures how a small AI effort can grow into a real operational system. The difference between a quick path and a durable one is often where the important lesson sits. The first version is usually enough to prove value, but it is still rough and limited. The useful question is whether the work should stay experimental or be redesigned into something dependable. That early setup is a practical starting point. It gets a narrow feature working without overbuilding. It moves traffic, but it does not yet solve the deeper system problem. Once the work is inside the customer's process, the limiting factor may shift away from model accuracy. A messy intake flow, a better intermediate draft, or approval delay can matter more than the model itself. That is the point where a prototype turns into an operating system for the work. The focus moves to reliability, visibility, control, and how the output reaches production safely. A system can appear functional and still point the team in the wrong direction. If you only check whether it still works, you can miss the fact that the entire process needs a new path. That comparison keeps the work honest. The real job is not preserving the original plan. It is keeping attention on the problem where improvement will matter most. This part separates the messy starting point from the system the FD helps shape. The useful habit is to compare the state before involvement with the evidence of change after deployment. A lot of confusion comes from mixing those two states together. Once the comparison is explicit, it becomes much easier to see what the FD actually contributed and what still needs work. Before the FD steps in, the problem is usually still fuzzy. The team may have symptoms, complaints, and rough ideas, but not yet a reliable plan for turning that into an AI workflow. That usually means people are doing the work by hand, and the process depends on individual judgment or memory. It works only as long as volume stays low and everyone follows the same informal habits. At this stage, the request for AI is often broader than the actual need. The FD has to pin the idea to observed work, because assumptions alone rarely produce a system that people trust. Data may be present in the organization, but that does not mean it is ready for use. It might be incomplete, scattered across systems, or too messy to support dependable model behavior. A workable AI system also needs clear rules around who can see what, who can approve what, and what must be reviewed. If those boundaries are vague, the technical solution stalls before it can be safely used. Different people often think they're solving different problems, even inside the same company. The FD has to reconcile those views into one operational definition of success. Once the situation is clear, the work shifts to structure. The FD turns a vague request into a system design, a workflow, and a set of controls that can actually run in the real world. That architecture spells out the moving parts, what a model is called, where context is retrieved, where a person must review, and what gets logged or blocked. The point is not just to make it work once, but to make the path of every action visible and manageable. A good workflow separates machine work from human judgment. The system handles the repeatable pieces, while people stay in charge of decisions that need context, responsibility, or escalation. Evaluation comes early, not after the fact. The team needs evidence that the outputs are good enough, safe enough, and stable enough before the system is allowed to scale. Those guardrails make the system governable. Approval steps, audit logs, fallback paths, and permission checks all reduce the chance that a small model mistake turns into an operational problem. The final piece is transferability. The customer needs documentation, examples, and operating guidance so the system can survive after the FD leaves the room. Deployment only matters if people actually use the system and the workflow changes in practice. The adoption signals tell you whether the design is becoming part of daily work or just sitting beside it. The first signal is simple. The right people are using it in the way it was designed to be used. If they bypass it, the system may exist technically, but not operationally. Adoption should also show up in efficiency. When the system is helping people finish faster, make fewer mistakes, and escalate less often, it is creating actual value. Trust matters because many enterprise AI systems stay supervised. If reviewers keep rejecting or ignoring the output, the model has not earned a stable place in the process. Real workflows always have edge cases. The question is whether those exceptions go through an expected path instead of becoming ad hoc decisions that nobody can trace later. The monitoring layer matters too. Logs, alerts, and feedback loops give the customer enough information to tune the system, catch problems early, and make steady improvements. The value does not stop at delivery. The work also produces product learning that shapes the next version of the solution and often the next use case entirely. That tells the team where the real friction lives. Sometimes the hardest step is not the model itself, but the handoff, the review stage, or the surrounding business process. User behavior often breaks the original plan in useful ways. When people use the system differently than expected, the team learns what the real operating pattern looks like. The implementation details matter because small changes can have large effects. Prompt structure, business rules, and retrieval strategy all leave traces in the quality of the result. Safety learning comes from the controls that proved essential, not just the ones that look good on paper. That tells the team what must stay in place for the system to remain usable and governed. Once one workflow is running, the team can make better bets on the next one. The evidence from production helps rank where the same pattern will create the most value with the least risk. That is why this role reaches beyond implementation. Every deployment creates evidence about users, data, controls, and product direction, and that evidence guides the next round of work. LLM application architecture is the arrangement of the parts around the model, where requests enter, where context comes from, what gets decided before and after the call, and how the result reaches the rest of the product. That structure matters because the model is only one piece of the system. teams get stuck when they treat the whole product as if the model alone defines it. Real systems have several layers, and problems often come from the seams between them, not from the model by itself. That phrase points to the full layout of the application, not just the prompt and the response. Once you think in terms of parts and responsibilities, it becomes much easier to design, debug, and measure the system. The interface is where the request starts, so it shapes the kind of input the rest of the system has to handle. A chat window, a form, or an API endpoint all create different constraints. Business logic decides the route, whether to answer directly, gather more context, ask for approval, or hand off to another system. If that decision belongs in code, it stays reliable. If it gets buried in the model, it becomes harder to control. The model call is the core generation step, but it only works well when the inputs around are shaped correctly. The surrounding architecture determines what the model sees and how its output is used. Retrieval brings in facts or documents that the model should not have to memorize. That layer is what connects the language model to fresh, domain-specific information. Memory keeps track of useful state across turns when a task needs it. Without that layer, every exchange starts from zero, even when the workflow depends on continuity. Some steps still need a person in the loop, especially when the cost of a mistake is high. Architecture has to make room for that review instead of pretending the model can safely act alone. Observability tells you what happened, how often it happened, and when the system starts to drift. Fallbacks matter because a production workflow needs a safe path when the model is wrong, slow, or unavailable. The output usually has to land somewhere else: a ticketing system, a database, a workflow engine, or another service. If that handoff is not designed carefully, the model may produce a good answer that still fails in the product. A forward-deployed engineer needs a clean map of responsibility. If business rules are hidden in the model, the system gets fragile. If humans do work the system could automate, the process stays slow. If observability is missing, no one can tell whether the deployment is helping or drifting. That map is what makes measurement meaningful. You can only judge the health of the engagement when you know which layer is producing the result you are seeing. Human/AI workflow design is about the boundary between people and models, because that boundary determines whether the system actually works in practice. The handoff, the timing, and the fallback behavior are part of the product, not an afterthought. Most enterprise systems still rely on collaboration rather than full automation. The model does some of the work well, and the human fills in judgment, accountability, and context where the model is weaker. That design work starts by assigning responsibilities. The main question is not whether AI can help, but exactly which parts of the task belong to the model and which parts still need a person. Good candidates for the model are repetitive first-pass tasks. Drafting, classification, ranking, and suggestion all fit that pattern because they speed up the workflow without requiring final judgment on every case. The human step belongs where accuracy, policy, or risk matters most. Review and approval turn the model's output into something the organization can trust, and escalation handles the cases that are too uncertain or too important to automate. Handoffs matter because the work has to move cleanly from one actor to the other. If the interface is awkward or the timing is off, people lose time and the model's value gets buried. Uncertainty and missing data need an explicit path. A strong workflow says what happens when confidence is low, fields are empty, or the model cannot safely decide on its own. This seam is often the difference between a tool people use and one they ignore. A result that arrives too late, in the wrong format, or with the wrong confidence is almost as bad as no result at all, and a heavy review loop can slow the whole operation to a crawl. The real test is whether the combined process helps people finish the job better than the old way. Model accuracy matters, but the larger question is whether the whole system produces faster, safer, more reliable work. Deployment becomes safer when decisions are anchored in evaluation, not guesswork. The idea is to test the system against clear criteria before anyone treats it as ready. That means the team agrees on what good enough looks like before rollout. Without that, a prototype can feel convincing while still missing the reliability or quality the real workflow needs. For an enterprise system, the evaluation has to cover more than model quality in isolation. It needs to reflect how the system behaves in production for real users on real work. Accuracy matters first because the output has to meet the job's basic standard. If the system is wrong too often, nothing else will compensate for that. Consistency tells you whether the system behaves predictably when the input changes only a little. That matters because users need stable behavior, not random swings from one prompt to the next. Safety depends on who will see the output and what harm a bad answer could cause. A system can look acceptable in a demo and still be unsuitable if the audience is exposed to risk. Acceptance rate shows whether people actually trust and use the output. If humans reject or override it too often, the system may be generating work instead of removing it. Benchmarks can hide the messy details of daily work. The better question is whether the system shortens a process, reduces errors, or helps people finish the task with less effort. The goal is not a lab result that looks impressive on paper. The goal is something that still holds up when users, edge cases, and operational pressure show up together. That discipline means asking for evidence of real adoption, not just optimism. Depending on the workflow, the evidence might be acceptance, correction rate, turnaround time, or escalation volume, but the rule stays the same. Measure the outcome that matters before calling it success. Agent behavior becomes a different problem the moment it can take actions on its own. The focus shifts from raw task quality to whether the system stays predictable, controllable, and safe enough to trust in real use. A model that only answers prompts can be checked with simple accuracy tests. Once it can call tools or move through steps, the evaluation has to include the whole chain of actions, because one good answer is no longer the full story. Reliability asks whether the system behaves the same way under real conditions, not just in a clean demo. Governance asks whether the right limits, approvals, and checks are in place so that behavior stays inside policy, risk tolerance, and business goals. Once an agent can make partial decisions, the evaluation has to cover control as well as quality. The question becomes not only whether it can do the job, but whether its autonomy is bounded in a way that the organization can manage. Safe failure means the system has a fallback path when confidence is low or something breaks. A good design lets it stop, defer, or hand off instead of making a bad action harder to undo. Permission boundaries matter because an agent should not have the same freedom at every step. The allowed actions need to match the task, the data, and the level of risk tied to the decision. Monitoring gives you visibility into what the system actually did, not just what it intended to do. Logs, alerts, and review signals make it possible to catch drift, abuse, or unexpected behavior early. Override paths are part of control design. A human should be able to step in when the model is wrong, the situation changes, or the risk level crosses a line. Exceptions are where governance becomes real. If unusual cases are never examined, the system can keep repeating the same mistake. So review turns edge cases into learning and policy updates. That changes the evaluation from pure performance to operational trust. A system can score well on a benchmark and still be unacceptable if the customer would be exposed to confusion, loss, or unmanaged risk. A technically strong deployment can still fail in production if nobody can control it or explain what happened. For an agent to count as a real business asset, it has to be both useful and accountable. A mid-engagement checklist keeps the work honest while the project is still in flight. It helps separate real progress from activity, and it shows when the effort needs a course correction. A short checklist like this gives an FD a concrete way to pause and inspect the engagement. The goal is not to score every detail, but to catch early signs that the work is producing value and still has the right shape. These questions cover the main failure points in a customer engagement. First, the system has to help a real user. Then the right people have to stay involved. Then the scope has to stay aligned with what the team has learned. From there, you check whether the team is still working on the highest leverage problem, whether the architecture is clear, whether the evaluation proves usefulness in practice, and whether governance gives the customer control and recovery paths. A checklist cannot replace judgment because real engagements always have edge cases and trade-offs. Its job is to warn you when the energy in the room is running ahead of the evidence on the ground. The job market signal comes from judgment, not just speed. What matters here is the ability to tell whether the work is headed toward a real business outcome or just toward more activity. Hiring managers look for more than fast delivery. They want someone who can look at the work while it is still in motion and decide whether it is solving the right problem for the customer. That kind of judgment saves time because it stops teams from polishing the wrong thing. It also builds credibility with product, sales, and customers, since you can explain when to keep experimenting and when to turn the result into something durable. That matters in any market, but enterprise AI raises the bar because a model that runs is not enough. The real value comes from choosing the system that changes the workflow in a meaningful way. This part turns the earlier ideas into a decision rule you can actually use under pressure. The point is to judge progress against the highest leverage problem, because that is where the real value or the real risk shows up. A project can look healthy on paper and still miss the issue that matters most. Time to first value, stakeholder engagement frequency, and scope fit are useful signals, but they only make sense when you read them through the actual workflow. The architecture, the human/AI seam, evaluation, and governance. Production value means the work is changing something real for users or the business. When that is happening, the effort deserves to continue. When the main outcome is just keeping an old plan alive, the safer move is to stop and examine whether the plan itself has gone stale. That self-check keeps an FD from drifting along with momentum instead of judgment. The next useful step is to turn these checks into a compact reference, so you can use them quickly when the pace leaves no room to think from scratch. This part turns the chapter into a working reference, something you can use when a meeting is messy, the goal is unclear, and a decision still has to be made. The focus is on practical judgment, not theory for its own sake. The chapter is aiming at usable skill, not just understanding. When an FD walks into a live customer situation, the value comes from having a repeatable way to move from idea to action. A system can impress people and still fail in practice. Adoption means it works inside real constraints. Messy data, access rules, review steps, compliance, and the internal realities that shape how people actually get work done. That image of a field card is useful because it implies speed and portability. If a method is small enough to carry into the engagement and strong enough to guide decisions there, it has been distilled correctly. That practitioner note captures the real test. A solution has to survive ordinary use, not just a first successful run. The challenge is consistency under normal constraints, because that is where adoption either holds or falls apart. This part gives the working field guide for an FDE engagement, a compact sequence for turning an unclear opportunity into something the customer can actually use. The point is to keep the whole life cycle visible at once, from the first problem framing all the way to handoff or stop decisions. Think of this as the label on the card. It signals that the page is meant for fast reference during real work, not as a long narrative or a slide full of theory. The sequence starts with the problem the customer actually cares about, then narrows to the smallest useful slice. After that, it focuses on where people and AI meet, how the workflow gets built end-to-end, and whether real usage shows up in production. The last steps are about hardening what works, transferring ownership, and deciding if the next cycle is still worth the effort. That layout matters because the page needs to work like an artifact, not just a note. A team should be able to print it, pin it up, and use the strip underneath as the quick path from one phase to the next. The same logic can be read as a flow instead of a table. That makes the movement easier to remember. Each phase leads naturally into the next one, and each one answers a different question about readiness. This line compresses the whole operating pattern into one path. It begins with a broken workflow, narrows to a wedge you can ship, then moves through design, integration, usage, and hardening before ending with ownership transfer and a fresh decision about what comes next. That image captures the change in quality. Before the FD work, the customer may have something promising but rough, with manual steps and fragile edges. After the work, the route is more predictable, with clearer roles, fewer surprises, and a repeatable way to get from request to result. This comparison shows the real shift FDE work creates. Not just a working demo, but a system that is scoped, connected, and measurable in the field. The important question is whether the surrounding workflow changed, because that is where durable value appears. A demo can look good even when the surrounding process is still broken. Real FDE work changes data flow, permissions, review steps, and how success is measured inside the customer environment. At the start, the problem is usually still broad and fuzzy. The team may know the general ambition, but not the exact user, workflow, or operational constraints that will decide whether the solution can actually ship. That kind of request points to a real need, but it is still too open to guide implementation. Until the use case is narrowed, the team cannot make good choices about interfaces, data, or evaluation. A model can produce a decent answer in isolation and still fail inside the real process. The hard part is fitting it into the steps people already use, where handoffs and exceptions matter. These are usually the blockers that surface first. If the team cannot tell which data is available, who can see it, and who signs off on actions, the project stalls before it becomes operational. Those goals sound positive, but they do not tell you what to build or what to measure. FDE work replaces vague ambition with concrete outcome definitions that the field can actually validate. Once FD is involved, the project becomes specific. The team is forced to choose a user, a workflow, and a measurable outcome, so the work can be tested in the conditions that matter. That narrowing matters because it changes every later decision. A system built for one job and one user path can be integrated, reviewed, and measured much more reliably than a generic promise. Now the AI sits inside the customer's actual operating context. It has to respect access rules, use the right sources, and produce results that fit the business process instead of a toy environment. This is where safety becomes concrete. The team marks the places where a person must confirm, correct, or approve, especially when a mistake will be expensive or hard to undo. At that point, success shows up in operational numbers, not just opinions. Fewer escalations, faster turnaround, cleaner handoffs, and less manual rework all tell you the system is doing useful work. That feedback loop is one of the biggest values of FDE work. Users reveal where trust breaks, where the edge cases are, and which missing capability would unlock the next step. That is why the field matters beyond deployment. It is the place where product decisions get grounded in real behavior. So the next version is shaped by evidence instead of guesses. An FDE sits where product, data, systems, and customer needs meet. The useful question is not whether the role is technical or customer-facing, but which parts of the system it has to connect so work can actually move forward. That seam crossing matters because many problems are not inside one team's box. A good FD helps turn a handoff-heavy problem into something the customer can test, use, and trust. A better way to picture the job is as a set of different surfaces the engineer has to touch. Some are technical, some are operational, and some are about making the workflow workable for real people. On the code side, the goal is usually not a perfect final system. It is a prototype or integration path that proves the idea can work inside the customer's environment. Data work matters because model quality depends on what goes in and what can be accessed. Choosing sources, cleaning them up, and handling permissions are often the difference between a demo and something usable. Infrastructure is where the prototype meets reality. Deployment limits, slow responses, missing logs, or weak access control can break confidence even when the core idea is good. Workflow design asks where the AI belongs in the customer's process and who checks its work. That includes deciding the point where humans should step in instead of letting the system run alone. Security is not an add-on here. An FD has to think about sensitive data, limit unnecessary exposure, and stay inside the boundaries the customer expects. Handoff is what makes the work durable after the first build. Good documentation, training, and run books help the customer own the system instead of depending on the original builder forever. That mix is why the role is bigger than implementation and narrower than generic consulting. The FD builds enough to prove value, translates between teams, designs the shape of the system, and helps it survive the handoff. A concrete customer service workflow makes the FD idea much easier to see. The important shift is not just adding AI, but redesigning one real path so the work becomes faster, safer, and easier to manage. In a manual version, the agent has to jump between systems and ask for human verification before anything reaches the customer. That kind of friction is exactly where a focused AI engagement can help, because the work is repeated often and the handoffs are predictable. Trying to automate the whole idea of customer service is too broad to be useful. The better move is to pick one bounded workflow and improve that path end to end, so the system has clear rules, clear ownership, and clear measures of success. Start with a case that comes up again and again, because repetition gives you enough examples to design against. A narrow case type also makes it easier to see whether the model is actually helping or just adding complexity. The boundary matters. The model can do the first pass on the response, but the human checkpoint protects quality and keeps responsibility clear, especially when the answer affects policy or customer trust. The answer should come from the same policy source the team already trusts, not from a guess or a stale copy. That connection keeps the model aligned with current rules and reduces the chance of inconsistent replies. Logging makes the system observable. Once the team can see where the model was confident, where it hesitated, and where people changed the result, they can spot failure patterns instead of treating every mistake as an isolated surprise. The useful metrics are operational ones: how fast the case moves and how much routine review disappears. If those numbers improve, the redesign is doing real work rather than just adding an AI layer on top of the old process. Failures are not the end of the process. They're input for the next design pass. Each bad case shows where the workflow, the prompts, or the policy connection needs to be tightened. That is why the highway metaphor works. The team still serves customers from the same starting point to the same ending point, but the route is cleaner, more reliable, and much easier to travel at scale. The practical test is whether the checklist keeps work focused and finite. It matters because field work can easily stretch in an open-ended involvement unless someone keeps asking what still deserves effort. A good checklist is a guardrail, not paperwork. It helps the team keep momentum while stopping the habit of drifting into tasks that no longer add value. Those questions force the work to stay concrete. They move from diagnosis to scope, then to implementation, adoption, and ownership, so the team keeps checking both technical progress and whether the customer can actually carry it forward. That final judgment is what protects the role from turning into support for a bad plan. Speed matters, but it only matters when it is paired with the discipline to stop, shrink, or redirect before effort goes to waste. The checklist is doing more than organizing tasks. It reveals the kind of person teams need for FDE work. What matters here is the mix of technical skill, judgment, and customer awareness that sits behind each item. A hiring manager is looking for someone who can handle shifting requirements, understand how a customer actually works, and still make safe choices in production. That means the interview signal comes from how a person thinks across messy boundaries, not just from whether they can write correct code. That rarity comes from holding the whole engagement in mind at once. A strong candidate can build the solution, scope it realistically, and then hand it off cleanly so the work survives after they leave. The useful test is whether you can turn a fuzzy request into a narrow, measurable workflow and hand it off cleanly. That captures the core job of an FD. Make the work concrete, make it repeatable, and reduce the need for your constant involvement. A vague customer problem has to become something specific enough to build, verify, and run in production. The handoff matters just as much because a solution that only works while you're standing there has not really solved the customer's problem. When the pace picks up, memory is the first thing to fail, so a small reference keeps the critical steps from getting lost. That leads naturally to the next concern, a practical aid that helps the team stay aligned while the engagement keeps changing.